everyone. We are going live in 10 seconds. Okay. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
Hello, everyone. Welcome back. It's a great honor for us to invite our old friend, Gilles Resting, because a lot of young students in China all know Gilles' name because of his project, his research over the past few years. So thanks, also thanks a lot to all the participants. We have some PhD candidates in this Zoom space. At the same time, we have Bilibili stream live and YouTube stream live parallel going on as well. So I would like to firstly introduce Professor Gilles Resting, who is widely recognized for his work on discrete architecture and application of computational design and robotic fabrication and digital fabrication, and which is who is the program director of the MARC architecture design at UCL Bartlett, as well as the co-founder of UCL AUAR Labs, and which research into new design and fabrication technologies. And it's a spin-out company, AUAR Limited Company, and works towards an automatic platform for affordable housing. His design work and critical discourse has been internationally recognized through awards, lectures, and exhibitions at numerous major cultural institutions such as New York MoMA and the Royal Academy in London and the Centre Pompidou in Paris. So let's welcome Gilles coming to give us a lecture. The screen is yours.
Thank you, Philip, for the generous invitation. I'm very, very pleased to be somehow back with you in Shanghai, although it is over Zoom. It's been a great event. I've been following all the videos online, many hours of fantastic lectures, and I'm very, very honored that I can be a part of this and contribute something to the discourse and to the discussion. So I'll share my screen. Right. So my talk today is titled The Discrete Automating Architecture, and I really want to unpack a little bit the various aspects of the discrete for everyone attending the conference today and for the audience. So we published this issue of AD now about 2 years ago. It's about time to also bring back together everyone who was in this issue to evaluate where the discourse is now and where we are now with thinking about discrete systems. Arguably, it has had quite a big impact globally. There's a lot of new plugins also being developed for Grasshopper and various other platforms where people are experimenting. But most importantly, I think today what I want to really talk about is about clarifying kind of the manifold of implications of the discrete, that it's not just a kind of stylistic project where things just look like aggregated elements or kind of like a kind of pure aesthetic project, but that there is also really important political and social aspects to the work, as well as technical aspects. And I think that is really crucial. Sometimes if you browse through platforms like Pinterest, like this is Pinterest who has learned about what the discrete is. It has used its machine learning algorithms to detect and classify what the discrete is from a kind of superficial aesthetic stylistic level. But I think it's important to kind of dive deeper into what it means as a kind of a paradigm. And as a side note, that is not to say that aesthetics are not important. I think they're actually really important as part of the discourse. So as a kind of maybe a small definition to start with, I think in the most generic way, you could say that the discrete is invested in the digital distribution of parts as the basis for an automated, complex, and equitable architecture. And that's a very open and very kind of generic definition. Now, the context for this work is very specific. So the discrete, I think, really started as a group of people many friends and colleagues who actually also have been involved here with Digital Futures, who realized that after the financial crisis of 2008, that there was something lacking in digital discourse up to that date. A kind of a lack to respond to a renewed sense of crisis and urgency that was in the world, that goes from like the global climate crisis to the global housing crisis, to questions about the consequences of the automation of labor, to even issues now that are on the agenda from identity and things like Black Lives Matters. I think this slide has figured in most of the presenters over the past few weeks in one form or another at the conference. The renewed sense of urgency, the context that is shaping digital work now, I would say, is really that the world needs to build 2 billion new homes over the next 80 years. And we need to do that in a way that doesn't destroy the planet. We need to do that in a way that is sustainable, but also hopefully that is inspiring and equitable. And it's really amazing to see, like I watched kind of, you know, all of the kind of lectures over the past few days. And it's really incredible how I think in a space of about maybe less than a decade, that this really has become something that everyone talks about and that everyone kind of realizes a renewed sense of urgency. And that's a very different situation than when we look back at 2008. You know, more than a decade ago, when the digital was still very much, I think, a project that came out of a certain period of time that you could describe as a kind of a neoliberal decade. It was a project that was very optimistic and that was really driven by kind of hedonistic formal exploration, which again, I mean, has its value in its own right, but that didn't really have a kind of a social or political agenda, and that or that was agnostic to that agenda, you could say, and that in many ways also didn't necessarily think about the digital beyond a kind of a pure formal discourse, and what was failing to kind of understand that the digital is something that is also reconfiguring our lives on many different levels. And digital discourse up until recently, I think, was really still deeply indebted to a discourse from the 90s, a discourse that came out of American formalism, that came out of Eisenman and Greg Lynn, and I was really invested in a kind of a dialectic with modernism. The idea that the digital was the polar opposite of modernism. If modernism was all about assemblies and parts, then the digital was all about organic form, no parts, continuous differentiation. And it's remarkable, as Mario Carpo has argued, that the very first digitally constructed building was a fish by Frank Gehry, which shows in a way a paradigm that has continued up until today. The idea that what digital tools, the main power for the built environment, that it is that they can allow us to mass customize complex, continuous, curved form. Before, this was unaffordable, but now that we have digital machines, we can create extreme difference in part organizations, and as such we can dismiss the part and kind of construct this continuous forms. But I think that in reality, if we look critically at things like even our relationship with modernism, we see that it's much more ambiguous, that there is not a kind of a clear dialectic to be drawn. That when we compare these images here of the Ford factory, which is the kind of epitome of modernist mechanized production, the serial repetition, both in the architecture and in the car itself, the fact that it's not customized, also the idea of labor behind it, the idea that everyone working in this factory would be able to afford their own car at some point. When we compare that now today with what arguably is the space of digital production, the Amazon warehouse, that is actually how digital production looks like. It's not a kind of a very formal endeavor. It's a purely logistical project about the distribution of parts and platforms across the world. And what we see between these images is a kind of an ambiguous and strange relationship. On a kind of formal level, they look similar, but in fact, nothing in these two images is the same. Like the way that things are organized on the right is radically different from how they're organized on the left. And also, again, the kind of political social consequences of this is that the idea of labor on the right and the idea of labor on the left are fundamentally different. The idea of society is fundamentally different. So this kind of brings me to this graph, which I will use throughout my talk today. Is a kind of the question if you could find a non-dialectical response to modernism, and also to the kind of the legacy of the digital. Could we find a kind of, begin to craft a kind of an alternative paradigm to think about digital design that disconnects from this kind of tropes of the 90s? And it's really all in that kind of little sentence. Like, I think if you want to think what is the discrete, it's literally just thinking in a digital way about the distribution of parts. And that word distribution is important, right? Because you could read it politically. Who is it being distributed to? Who benefits from the distribution? Who's in power of that distribution? You could read it economically. You could talk about platforms and models for distribution, but you could also read it architecturally. You could also talk about the consequences of the distribution of parts, the way that we experience it, the way that we look at it. And that then also can lead into kind of philosophical considerations of distribution. Mariologists and ontologists of parts. Now, so that's kind of the setup for the talk. So I have divided the talk in 3 chapters. One about the technical logic of the discrete, one about the architectural logic, and one about the socio-political logic. And they could be switched around. You could start with the socio-political order, you could start with the technical logic, or with the architectural one. So they were kind of in I just decided to start today with the technical logic. And I think it's also important to say that while I've discretized the talk into these 3 aspects are always continuously interwoven. And I think it's also important to make an argument that any kind of architectural paradigm ultimately, I think, needs to thrive on those 3 aspects. When one of those aspects is missing, something is missing. So if you only talk about technical tools, you're not necessarily building a kind of different understanding of architecture in itself. And if you only talk about aesthetics, neither, or only about social politicals, neither. It's very important that they're always all 3 present. Now for the talk, I further discretize this. So the technical aspects I will discuss through the work that I'm doing with our labs at the Bartlett and with the Bartlett B-Pro prospective program, where I'm the director of the MArch architectural design. So I'll be showing student work. Then the architectural aspects I will discuss through my own practice, which is, I always joke, a kind of a traditional architectural practice, which is trying to build buildings and operate with a traditional business model for architecture. And then the social political aspects I will explain through a recent endeavor, which is a new company that I founded together with my colleagues, Molly Claypool, Manuel Jimenez, and Claire McAndrew as a spin-out from our lab at UCL. So this is a platform company that is called also Our Automated Architecture. Great, so first chapter, so the technical logic of the discrete. And you will see that I always, for every chapter, I will bring back this diagram. So the technical logic of the discrete, you could really understand as the kind of the question when we are building buildings, how do, what is the kind of the technical ideas between the way, in the way that we organize those buildings, right? So what is the difference between, for example, modernist prefabrication and discrete fabrication? What is the difference between digital fabrication in a discrete paradigm versus digital fabrication in a continuous paradigm? And the context for this, and again, this has been mentioned in many of the talks before, which I'm very pleased about, is the fact that it's very urgent that we revisit that we revisit the way that buildings are being constructed. The building industry is the least digitized industry in the world, and productivity in the building industry has flatlined, at least in the West. I don't think so in China necessarily, but in the West it has flatlined since 1947, which means that essentially you could argue that architecture on a kind of very fundamental, blunt level has not actually changed since 1947. So despite all our efforts with BIM, with robotics, with new materials, we're still not building more efficiently or more productively since 1947. And 1947 is the year that Le Corbusier started building l'unité d'habitation in Marseille, just to put that into context. That also means, again, that this kind of non-dialectical relationship with modernism, it means that modernism is really resistant. It's really reluctant to go. We're still indebted to this model of the maison domino that is still kind of present and persistent in construction up until today. And I thought it was very beautiful that Jaime also showed his project at the Venice Biennale, which was attacking this model, right? This kind of persistent model of the domino. Now, in the context of today, there are efforts in changing and in disrupting how the building industry works. Most famously, there was the combination in a way of sidewalk labs and Katera in the US, with Katera again relying on a kind of very old-fashioned in a way idea of modernist prefabrication with a kind of a modular kit of parts that is done not in concrete but in timber, but as an idea kind of came straight from the 1950s. And now, of course, the context is that 2 weeks ago that Katera went bankrupt after burning through $2 billion in funding, which is incredible, right? So someone has thrown $2 billion in funding to change the building industry, and that attempt has failed, right? One of the biggest attempts ever to change the way that we build has not worked out. And I would argue in part that is also because of a design problem. If you look at Katera, it was actually operating, I always joked, as a kind of a venture capitalist version of a Soviet housing factory, of a very old-fashioned idea about vertical integration of prefabrication, the need to build enormous factories and the need to build enormous systems of top-down vertical control to run this centralized factory. So it's actually kind of a very old mechanized idea of production, which again, the persistence of that modernist paradigm that underlies this. But that also opens up really this kind of key question, the question how today we can rethink prefabrication and modularity in architecture. We all know that this is the way out of the stagnant productivity. Everyone is looking at offsite production, but the question is, can we really kind of rethink prefabrication and modularity and disconnect it from its kind of modernist legacy? And so this is where that's kind of ideas of digital fabrication can come in. So rather than thinking about digital fabrication as digital craft, as you see on the left, you could also begin to think about digital fabrication as something that is purely about organization and logistics, and that is not about the kind of digitized version of craft. And there are technical precedents for this. So there's this very beautiful work by Hod Lipson, which is by now, I believe, like 2 or even 3 decades old, where they're looking at forms of 3D printing, which are actually assembly of voxels rather than a kind of a crafting of forms, which is really, really radical, right? So we're actually building forms not by continuously crafting or by subtracting or adding material, but actually by stacking these kind of tiny little bricks together. And then that work also, one of the key references there is, of course, a work by Neil Gershenfeld at the Center for Bits and Atoms in collaboration with NASA in many instances, where a similar idea is proposed of this kind of Lego-like, modular, bit-like building blocks that are actually not really architectural elements. They never have a pre-described function. They're always functionless, and function only emerges after their assembly. So although they are elements, they're actually to be considered materials, and they're also described as that. So they're not actually kind of architectural elements or parts as such, but they're actually really large-scale materials, you could say. They're optimized for robotic assembly. And then the idea is that within a kind of a mechanical engineering paradigm that you could build any kind of machine with this, such as an airplane here that is built, again, of an aggregation of those Lego blocks. We could also look at the work of the Wyss Institute at Harvard, where, again, there is a kind of a really interesting connection to swarm intelligence and emergence, where swarms of robots are stacking this kind of modular basic building blocks into larger structures, and where there's a deep relationship between the kind of form and organization of those elements and the logic of robotic assembly. So this is really the kind of, in summary, the kind of interesting idea, like, could we actually think about architectural elements not as kind of modernist types, so not as columns, beams, bricks, but could we think about them as materials? Could we think about them as digital materials, as elements that have no specific function, but that could be aggregated together with other elements and then emerge in functional structures? And it also has important consequences, of course, for automation, because currently the current building industry is based on a kind of a modernist tectonic, where you have more than 7,000 different parts and pieces that are sourced from all over the world, that have no specific relationship to each other. If you want to automate architecture as it is today, you will always end up in a way as Catera. You will need $2 billion and you will go bankrupt because it's just impossible. You cannot automate architecture as it is today. You need to radically simplify it, make it even kind of more blunt in order to work. So that is also a kind of a beginning. Already you can see that as well here, a kind of a beginning of a design challenge that in a way, if you want to automate that, we need to also rethink the kind of core syntax of architecture. So architecture in a kind of fully automated way, thinking about these modular parts that have no specific function, architecture then becomes a pure matter of organization, a pure kind of blunt stacking without any kind of form of craft. It's just a pure organization of similar parts. So this is work that we've been investigating now for a number of years at the Bartlett School of Architecture with our lab and in the teaching, where we're developing this kind of functionless material-like elements that can be assembled by robots, by industrial robots today, but also by our own kind of versions of swarming robots that can assemble those bits and pieces. And this one I always like to show that, which we call the pizza bot. The orange element is a robot, the white element is a brick. And this is kind of, you could say kind of very blue sky vision of what a kind of a fully automated architecture could be in this world. So you see this kind of pizza bot here hopping, walking through the Bartlett, through the corridors where students build that and kind of speculate on how it works. Then larger versions of this with a kind of robotic assembly that is simulating the movement of these robots. And then also now looking at reinforcement learning, where we're using ML agents in Unity as a framework to actually train those robots to make their own decisions rather than explicitly programming them. And then resulting ultimately in a kind of vision of what that kind of strange form of swarm assembly could look like. Like you see here, kind of hundreds of these robots assembling thousands of these bricks, and the building almost kind of growing, which again is in a kind of a strange contradiction almost to the kind of seemingly repetitive logic of the parts. So that kind of vision of what modularity in the digital age could be like. And now in kind of recent efforts, I didn't bring any student work from this year. We are still very busy preparing for our super crits at the Bartlett in 2 weeks from now. But also again, like now we're looking actually quite actively at various forms of machine learning to train assemblies of these blocks and to help us evaluate and generate various designs. So this actually worked from last year from a group called Public Parts, which was also again looking at reinforcement learning to aggregate various building elements in a platform, but also considering kind of larger consequences for what it means to live in those buildings, right? And questioning also the kind of the fixity of these elements. What if these elements could also kind of, or some of these elements could change over time? What if the robot kind of keeps living in those buildings? So here there's a very beautiful project also from last year where there is a kind of a robotic element that has a very limited behavior, can just move forward or backwards. But in doing that, it reconfigures the typology of a building and changes its kind of use over time. We're also interested in various forms of materials. Like for example, here we have been working with bamboo and augmented reality, where we used also again machine learning to kind of extract various aspects of bamboo rods and then generate assemblies. And ultimately all this work kind of with my students, not only at the Bartlett, but also, for example, here at RMIT in Australia and at Hong Kong University, is always kind of invested ultimately in developing this like fully automated housing proposals, right? And kind of looking then as the end goal of all of these technical exercises is really how could we build housing in a fundamentally different way that you know kind of capitalizes on the efficiencies, this kind of radical efficiencies of prefabrication and modularity, but at the same time in a completely digital manner to ultimately enable forms of inhabitation and life that are very different from those today. So that's kind of just a little bit about the technical logic. So now I want to talk with you about the what I call the possibility of a discrete architecture, like approaching the discrete purely from a kind of architectural perspective, which is then, again, if you look back at this diagram, what are the kind of architectural differences between a modernist assembly, a continuous understanding of space, and then a kind of a discrete version of that. Like what is actually, when it would be built, what is a discrete architecture? And to illustrate this chapter, I will mainly look at work from my own practice. And you will also see that my own practice obviously operates in the right here and now. So it tries to bring research that we're doing at the lab to the real world, but also needs to operate within the kind of the constraints of the real world, right? So it's less blue sky and it's more applied. And again, maybe to start that conversation, I think it's very important to say that purely from a kind of a creative question, that for me, it was really obvious that we needed to do something with discreteness in the digital, because we had explored for about 3 decades ideas of continuity in relationship to the digital, but we had never questioned what actually the kind of polar opposite of that would be like, right? What would it actually be if you would still have parts and if you would still kind of look at issues like assembly? Because issues of assembly and parts are so fundamental to architecture. They're really kind of at the core of the discipline. It's the one thing that kind of, if you look at what architects are doing, you could always say that their endeavor is to bring thousands of different parts into coherent wholes in one way or another, and to develop kind of ideas and politics of the organization of those parts. So obviously the radical and incredible experiment of the early digital was to get rid of the parts and to imagine an architecture that had no parts, which, you know, in its own right is a kind of an incredible creative exercise. But you could also do the opposite, right? And you could also question kind of, okay, what we haven't really experimented with questions of digital assemblies and parts. And I produced this kind of really blunt historical diagram, which is kind of an overview of architectural history in the last century, like everything that happened in architecture, which I've set up again as a kind of a relationship to modernism. So of course you have modernism itself with the domino. Then you have postmodernism, which was the effort to diffuse the domino and to make its reading more contradictory. Then you have deconstructivism, which was making the domino more expensive and more complicated. And I mean, you could say a bit more wild and probably also more inspiring. So I kind of symbolically show the 2 dominoes intersecting. Then you have parametricism, which is cladding the domino into continuous panels to make it look like as if the domino does not exist and there is a kind of a continuous space. And then recent attempts in the US that are focused on making the domino appear as an object, more object-oriented ontologies as a kind of autonomous architectural piece. And then for me, it was kind of clear that you cannot kind of, you know, all these attempts try to kind of defeat or beat the domino, but none of them manage, right? They always still kind of rely on that domino. Whereas actually the kind of the discrete attempt in a funny way looks in this diagram, you could say exactly the same as the domino, yet it is the attempt that kind of got rid of the domino. And of course, like as a kind of a provocation, draw it up in the same way as the domino, also to argue that it doesn't really matter, but that ultimately the drawing on the right, the kind of the discrete version of that domino has nothing more in common with modernism. So it actually got rid of all the kind of materials and types and things that modernism is made of. And it becomes a kind of discrete aggregation of the same part repeating over and over and over, which in a funny way, then contradictory enough, again, results in a continuous space. And that's actually where I kind of want to very briefly take you through this journey, because the discrete and continuous are obviously always in relationship to each other. They're kind of in a toroidal space, where if you are really, really discrete, you end up being continuous. And maybe if you're extremely continuous, you can also end up being discrete. But in my case, my kind of journey in the discrete really started with my time at the Architectural Association, where I was a student then with Robert Stewart Smith, who back then was running Kokuja together with Roland Snooks. And my end of year project there was kind of this incredible fibrous agent-based assembly, which was the extremely high-res kind of extremely, you could say, continuous organization of material. Like there was literally nothing kind of repeating there. And it's extremely difficult to kind of identify what is a part or what is not a part. Although it is a kind of a digital form of assembly as well, you could argue, because it's a lot of agent bodies that have been assembled together. And for those of you who followed Roland's talk, you will know everything about this. And after I graduated from the AA and started my own practice and started teaching, with the practice, I started to do competitions, initially not immediately with the idea to win those competitions, but more as an idea to build a portfolio. And I kind of, the first step was to begin to discretize that continuous cloud. So what you see here is actually exactly the same as what you see in this image. The only difference is that the elements that are being computed are now so constrained that they can only form straight lines with a specific length, and they can only connect to each other under a specific angle, with the idea that actually to fabricate this thing, it would be a little bit easier than the previous element. It could all be made out of bent steel rods. And that then led to kind of a whole body of work that was continuing to explore the kind of gradual discretization and also kind of objectification of those processes. So kind of invested in, for example, here, looking at how to separate are different kind of elements in the building. And again, looking at these extreme high-res assemblies, right? And I think I always kind of compare that as well with minimalist art, which is this kind of very process-based kind of operation of the same logic over and over again. Like here, the kind of the trace of a pen on paper by Agnes Martin, which then results in this kind of minimal but subtle kind of form of differentiation, and also, a drawing that in a way is assembled. And that work, this kind of obsession with the kind of gradual assembly or like toolpath-like logic is also present then in experiments that we were doing with our robotically 3D printed chairs, which is a kind of a complete obsession with parts and toolpaths and kind of robotic logics of assembling tiny little pieces of fragments of toolpaths together. But then logically, if you further discretize, the question was asked, like, what if we actually start to work with completely repeating elements that are that have less and less exceptions and less different ways to connect to each other. So this resulted in this work, for example, here for the Block Hut, which is a villa in Belgium, which is kind of a crucial project for the practice because it's formed a kind of a very clear, I think, image of what I wanted to do as a practice. And it established this kind of strange architectural logic of something that is assembled, but that at the same time is kind of seems deeply natural, something that seems extremely novel, but at the same time also very old. Like it has this kind of, I think, complex layering of different qualities in there. Then work like this, which again has this kind of bizarre and strange relationship between something that we know, something that is familiar, and then something that is that we are completely not familiar with. I think this one, the Diamonds House, it's a project I did in Belgium, is one of the kind of best examples of what a discrete architecture could be like. Again, a kind of an assembly with repeating parts that are always the same over and over again, and that once assembled construct an almost continuous organic kind of space, right? Like almost kind of like the experience of being in a cave. And then very importantly with the practice was that the idea how to materialize this work. So we really started to work on establishing ways to build this. So based on a kind of very simple logic of always working with standard timber sheet materials that can be cut by robots or CNC machines, and then assembled together without any crafting on site. So they're just kind of post-tension together on site. So this is a pavilion we built in Tallinn, which was kind of an important case to reflect on the possibilities of that architecture. And again, I think for me, quite important to see how it is very similar to the Block Hut project. Like it's kind of to show that that kind of architecture is affordable and that we can actually build it. And again, the kind of the strange qualities of this architecture, I think, is the fact that you could organize discrete parts purely with engineering logic, which would give you the drawing on the left. You could also just pile them randomly, which is what you would do in the middle. And those are actually two really logical ways of working with discrete parts. But I think the strange quality in the way that I work with those parts is that they're always articulating something that we're slightly familiar with, as like for example, the slap-like domino or other work. And it's this kind of strange confrontation between what we know and what we don't know that generates its qualities. Then here for, this pavilion obviously was like a domino in the sense that it wanted to talk about housing and about how we could consider housing differently. And then a series of other projects where this is at the Royal Academy, where we managed to kind of build a section of that Diamonds House project that I was showing before. And again, exploring kind of the qualities of that building. And we've managed to kind of keep prototyping these systems. And now this is a project that we've just built. It's tiny, a very, very small project in Belgium, where we constructed a very simple square, actually a square that rests on 3 feet, on 3 support points between 2 walls. But it's actually not supported by those walls. It's really kind of a timber table that is built of this prefabricated blocks. They're made of a kind of a mini CLT material. A very strange building site where these elements are literally, like there's no craft on the building site. It's literally just clicking together these components and gradually kind of, you get a kind of gradually emerging functionality out of those parts. See here the roof. And I think it's very important to mention that, this is a very kind of humble project. It's not for a kind of a funky, wealthy client. It's actually on a very normal budget, the kind of the typical budgets that are available for this like small house extensions back in Belgium. But I think it offers a kind of extraordinary spatial quality and a kind of a really like for me, it was really kind of important to be able to show that we could tackle such a kind of normal, simple, humble projects with these construction systems and showing what they can add, right? And I think, again, it's kind of interesting from an architectural perspective, very domino-like. Like it's actually, as an architectural idea, very boring, that it's just a roof and a column, yet nothing in this building is a roof and a column. It's all kind of very different. And then you could speculate further with the same building systems, how we could build. Like this is a project in Romania, which we could literally build like it is. I know exactly how to do that. And again, it has, I think, this kind of incredible experience and logic to it, where it's kind of half assembled, half natural. It's also primitive, right? It's almost like a very primitive assembly where you take the material as it comes from the forest and you just kind of assemble it together. And then again, this relationship that it's at the same time, you could say really old and really new, that the really new architecture is actually the same as the really old one. And then importantly, this work is also scalable. So this is another project for a concert hall in Nuremberg, where we've worked with extremely large cross-laminated timber elements that could be robotically prefabricated, that are then discretely aggregated in a voxel space and result in this kind of building, which on the first view, you could say is really boring. It's just a box, but on second view, it's actually a box that has nothing in common with any way that you would, with anything that you would build today. Like there is no elements in this building, apart of the staircase and the glass facade, that you know from existing construction. Everything has been digitally fabricated and crafted. 90% of what you see in this image has actually been robotically cut, and I think that that's one of the kind of the most radical aspects of that building and of the discrete, right? It's not so much like that's actually one of the aspects that has the most radical impact on the building industry. Like it's reverting this kind of scenario that Rem Koolhaas pointed out, where architecture has been reduced to kind of a millimeters thin surface, and it's kind of expanding again that space to be monolithic, right? To kind of being able to bypass that commodification of architectural elements and make it again a kind of a monolithic and volumetric approach. And then you could apply that to different projects. So this is a museum in Helsinki, also for a competition, which is actually exactly the same as the concert hall. There's this kind of enormous prefabricated V-shaped chunks that have been aggregated. And again, this is just as the Nuremberg project is not a box. This is also not a shed or a gabled roof. It looks like a gabled roof, but it actually has nothing in common with a gabled roof, which is kind of, I think, quite interesting. And now we're taking some of those methodologies that we have developed for the concert hall and the Helsinki project. We're now taking that also on site. So we just got the building permit for this project also back in Belgium, which we're doing with Bollinger Grohmann, the engineers, and a very interesting timber manufacturer. Built again a kind of a very small project, but really this time working with industry and contractors together. So I'm almost running out of time. I think I have like 2 minutes more, so I'll try to speed this up a little bit to talk about the last chapter, which is very important, which is the kind of the social, political, and economic consequences or basis, you could say, of automation. So when we're looking at this kind of, again, at our 3 curves here, you could also look at these curves and purely ask, like, what are the kind of, the kind of political and economic questions behind this, right? Like, if we're thinking about modernist production, you need all these vertically integrated massive factories. They were usually also like state supported when it came to housing. Who owns those, right? Who's setting that into motion? If you look at continuity, like, what are the kind of political impacts of digital fabrication? What is its kind of position? And we've spoken already about kind of looking at it from a more political angle. With my colleagues, I've also written this book, Robotic Building, which foregrounds some of those questions of like the relationship, for example, with human labor. And it's really kind of an invitation to ask, like, what can we actually kind of consider a robot also from a social political perspective, and a kind of, in a way, kind of a call to arms to be more precise and provocative with understanding kind of larger consequences of the machines that we work with. And again, like many people here at Digital Futures, many good colleagues and friends were a part of this book as well. And what we kind of did, and that's the last thing that I want to talk about, is that we recently, in response to those kind of questions of platform economy and digital economy, we recently spin out a company from our research lab at UCL, which is called Our. And Our really is kind of very ambitiously a housing company. We want to change the way that housing is built today. I think some of the most interesting architectural experiments today are in that region, where architects start to become also developers and contractors at the same time. For example, Anton Garcia Brill with Warhol Systems, or Intelligent City and Vancouver, or WikiHouse, which are kind of extremely ambitious attempts to completely change the existing production chain of architecture. And it manages kind of to put architects in a very different position. Also, like it's not anymore service-based as a profession, but it becomes product-based. So we're attempting to do something similar with Our, where we've set up kind of a micro factory approach, where a simple robotically built building block can be assembled into a large variety of different architectural features. Up to the scale of housing, this block can be robotically prefabricated, so it can be nailed together with two different robots into a building block. And we've built our own office with this, but we also importantly are working with a number of community-led housing organizations where we're giving various stakeholders and participants and future inhabitants access to our automated tools, where they're actually working together alongside us and thinking what their spaces would look like, how they would want to live, and kind of are able, through the fact that we have automated large parts of this process, to kind of speculate with us on a horizontal level. So this is in Bristol with Noel West Media Center, where we have recently, with a group of participants, built a first prototype for housing. In this area, a lot of housing is being built, and we're basically working on establishing a kind of a micro factory approach to that housing, where together with the local inhabitants, we could build very different types of housing. So like this was called Block West, which was a first kind of pavilion installation that allowed people to understand the building system that some of them maybe in the future will be living in. So they could think alongside with us about the qualities of this system, understand how it's built, what its potentials are, what its problems are, etc. And kind of speculate really about if they would be building a house with our building system, how that would look like. And then we're speculating also on larger housing schemes. This is also in Bristol, kind of a first proposal for a larger housing scheme. And now we're going on site with 2 micro homes, which are kind of small, like tiny homes that we're building also with our building systems, which are for the first time now fully clad as well. And then as a last project to demonstrate our approach, we've recently built a 2-story prototype in Hackney in London, which was called House Block. So this was for us a kind of an incredibly important moment, because we could, in a really radical way, show that just with one building element, we were able to build all the kind of features from staircases to functional floor slabs, et cetera, et cetera. And again, kind of making this argument that like doing this kind of work that is politically and socially engaged, and that wants to do something in a way you could say good in the world, that wants to make affordable housing, that it doesn't mean that aesthetics are excluded, that it doesn't mean that that it needs to be boring per se, but that actually we're kind of working around those considerations of automated prefabrication, that it could also result in a kind of really different and really exciting architecture. So yeah, this hasn't been published yet, but this will be published soon. And again, it's kind of to be understood as a small housing prototype. Here the staircases and then the slabs panning out. Yeah, so that's it for me for today. I think it's my kind of key message that I want to send in a way is that when we are playing around with these discrete systems, to not kind of consider it only as a kind of an aesthetic project or as a kind of an algorithmic technical exercise in itself, but to kind of really consider that as a larger architectural paradigm where you could contribute something, talking also about its role in society and what it could mean for housing, what it could mean for how we build. Thank you so much.
Great, mind-blowing. So wonderful to see your project again. And I just wonder, where do you have such a big energy to do so many projects just in one or 2 years? It's very, last time you made a presentation was 2 years ago, I think.
I did one last year as well with Golden Snooks and Mario Kart, but that was very short.
That's a really short, right? Because 3 of you differences. But today is like a very holistic understanding of not only the project, but also most important is your theory. I think you have a special paradigm put forward, the discrete system rather than the atomic system. So actually, I think we have a lot of questions. I maybe firstly, because I know you very well and put forward a very difficult question to you to answer, maybe for discussion. So I think what you are doing is quite actually similar to my approaches over the past 10 years. A different culture, different industry, and different technology, but actually we're thinking a very similar way. So I can totally understand what you're doing. The first question goes to discrete system. So we have a lot of discussion on that, including with Patrick Schumacher, with Newlich, and with Philip Rock over the past few years, and talking about, because domino system is actually, that is a discrete system. One, I don't know in Europe, but in China, from the 30s, 40s, 50s, very early modern architecture, which is prefabricated, but the difference is, which is just consists of the components is column and slabs and windows and the enclosure facade. That's all separately prefabricated in the factory at the very urge of modernism. But after examined by the earthquake, you know, in 1996 in Tangshan, China, they have an extremely serious earthquake. And to prove that this system is not very safe, because the building are demolished by the very big earthquake. After that, after the 80s, I think China, we construct buildings, including, I think, around 30 years. It's a kind against the concrete, against the discrete system. It's just all on-site pouring of concrete is a kind of a system. But from the past, I think 5 years ago, the government still go back to the prefabrication system, and that not go direct to a stylistic way. But maybe that's not right to make a description of you. But I think that goes to different components which could be prefabricated. But the main steps go firstly to the material performance and the industry organization. Maybe we name it as PC as a kind of concrete system, and we have timber as like a prefabricated timber system. So it's all categorized by different kind of material or different kind of the height of the building, system of the building. Maybe super high rise could be a prefabricated one, and also 1 or 2 story could be a prefabricated one. But the regulation and all the practice is totally different. So first question goes to you. How would you like to define your discrete system with domino, although they are the same? So you are talking about that. From my understanding, what's the same, initial same, and what's the key scientific question we need to solve in our age, in recent age? What's the difference between this discrete rather than Lacoupe's discrete system?
Yeah, it's a super interesting question. I've actually discussed this. This reminds me, a number of years ago, Patrick Schumacher asked me the same question. So we had like a roundtable discussion on the difference between the notion of the part in a modernist paradigm and then in the kind of discrete paradigm. And you're obviously right to say that the domino is a discrete system, because I mean, architecture, if you look at prefabrication, consists of discrete elements that are put together and that can also even be assembled in different ways. But it's not a digital discrete system, right? So it's a kind of an understanding basically that every part is optimized for a specific function and a specific performance, which results in types of assemblies that are completely closed. So they're not open-ended. They always result in a kind of a homogeneous understanding of space, that every domino per definition is the same domino across the world. And it precludes kind of the kind of complexity and open-endedness and customization that we associate with the digital, right? We can't really, it results in a kind of a form of inhabitation that is typified, where you have a 1-bedroom apartment, 2-bedroom apartment, studio that is completely closed. So that's kind of from an architectural perspective. I think that from a technical perspective, the difference essentially is that in a digital discrete system, that function is removed from the elements. They perform in a generic way, which then means that function only emerges after those elements are combined together. So you would never prefabricate a column or a floor slab, but you would only kind of, you would only end up with a floor slab after kind of recombination of elements. And I think what is important there, and I think that's when we look at these examples of companies like Atera, it's really important to kind of understand that this modernist approach to prefabrication, this mechanized approach, that it is not fully capitalizing on the potentials of the digital, that we end up with a system that still has this very long production chain. Every domino, as we know, the domino looks beautiful without cladding, but we all know that it needs to be clad, right? We know that it needs to be wrapped. And that's actually where the real problem starts, is that this domino is not a functional building, it's a skeleton, it's a carcass. And then it needs thousands and thousands of other parts and layers to be added to it to become functional. So when I'm saying that like architecture consists of 7,000 different parts and pieces and is impossible to automate, the source of that is actually this domino, because the domino is separating function. It's always looking at parts with specific functions. So you have a facade that has its own system, you have a floor that has its own system, a column that has its own system. So what we really need to do is to kind of get rid of this functional differentiation and really look at kind of more monolithic building systems. So that's kind of, I think, a technical agenda for that. I think it's really, really important as a kind of to look more at from a proper engineering perspective at how these parts work. And I think I've now been in a kind of a great position to slowly test it out together with various engineers, like with Klaas de Reyke, who's also involved with Digital Futures from Bollinger Grumman. I've been working with him for a while. And my engineer, Manja van der Worper, we've been starting to do like proper testing of this post-tensioning systems, etc. But there's a lot of, there's still a lot of testing to be done to find exactly this difficult question of what performance means in such a redundant system, right? Like what is the actual performance needed for those parts? And that's super interesting. And I mean, I also like to, like there's more and more people also working on this question. So I think it's becoming a more and more interesting debate to understand that.
Yeah. I think my understanding to the difference, probably it's produced a new opportunity to architects, because in the modernism, the industry go directly to the. I think it's a. For example, the column, the slabs, all same to each other, which is what you say, it's not digital design and digital fabricated. So industry goes to all the copy and paste. It's like the same copy, and that is goes to the very big factory. But right now, it's more gave the architects more free design possibilities, maybe that produce a new opportunity, redefine the industry. So the second question is interesting, go to the platform you mentioned. I think when we research on such kind of interesting topic, after years, you will all go to the platform, because it will to set a systematic work, how to redefine the relationship between the designer and fabricators. I actually invite you to come to Shanghai and see your team is really strong. For some small project, even though you have workers, probably your team play a very important role in the construction process. So how would you like to enlarge your skills of the buildings? Maybe in the small project, your partners and your team could play a very important role in that project. But if you enlarge them to a bigger scale, how would you like to address your systematic ways to control the building, and how would you like to engage in the process in the future?
Yeah, that's, again, I think super interesting, and at the core of the work, the challenges that we're facing now with the platform company that we're trying to do. Because it's true that obviously until now, I'm an architect who builds myself, and I have my team who is really good at questions of building. And for example, the first house that I was showing was built, by myself and my team. There was no contractor involved. because we felt it's just impossible to do this work with a contractor. There's such a big gap between the knowledge that is needed and like to make this happen. The interesting thing is now that the second house we are building with a contractor, but it's a very rare contractor because he's an absolutely fantastic, very intelligent timber contractor who is very open-minded. He's an engineer himself, so he's really, really interested. And I worked with him before for a competition, and that is a very easy transfer to industry because you have a very enlightened industry, which is normally not the case, as we all know. This is like not the real battle. This is, you're very spoiled if you can work with this kind of contractors. So the question then goes more to the platform that we are building, because obviously the platform wants to scale. It wants to not be the kind of typical architectural practice where you design like a beautiful house and a beautiful museum, but it really wants to be a big platform for housing. It wants to go viral. And it's also based in a way on the idea of distribution, because it's all about us building this micro factory, this little robotic cell, and then populating the country with multiple robotic cells and having people around these robotic cells be able to work. And I would say one kind of, we've worked a lot now in Bristol with involving people like stakeholders, so both small contractors and the people who will live in the buildings in the building process. So we teach them the skills, we teach them how you can connect those blocks together, how you build a block. We discuss with the contractors together how to do things like cladding. And for example, the two micro homes that I was showing, they are actually being built by the clients with one person of my team to kind of oversee the process. So that's very, very interesting. And then the idea is actually that the client, once they learn how to build one, they will become my contractor for the next ones. Okay. So some of this, so it's virally kind of connecting that they could help each other out. But then also, obviously, we all know that also has the limits. You can't build a big building like this. This is only for small projects. But you could imagine maybe to do a similar workflow with larger contractors for larger projects, that you kind of, that you involve them in that process very early on. And I would say that in terms of like, that's actually an advantage, Philip, of the discrete system, is that it has so few different joints and connections and things that you need to know to learn it. It's very easy to teach people how to build with this discrete method. So I think that is something that is quite a good aspect of thinking in scaling and building larger groups of people who know how to build with this, because it simplifies kind of the problem space significantly. But there's still a lot of work.
Yeah, I can imagine. So I just wonder how could you both teaching and very experimentally in your school at the same time you have so many projects coming out. So that's a wonderful lecture, and I can see your energy and your great successful projects coming out. So that's what we were talking about you years ago. We were talking about there is a future star rising up, and we can see the potential in your prototype research methodology. And we are curious on your future, because we want to see what will happen based on this methodology and this new paradigm shift. So great thanks to you, Gilles. We have some other session of the conference. So thanks for.
Thank you so much for the invite, Philip, and the great conversation.
Let's keep in touch, and I will
hope to see you soon. Yeah.
Yes. Bye bye. Bye bye.
Bye.
Okay, is Martin here? Oh, hi.
Hi, Philip. Hi. Good morning. Hi. Good day. Good afternoon. Thank you.
Good afternoon. Good morning. So, what time is it right now in your city?
It's 9:30 in the morning. So, like the.
Okay. Welcome.
It's so awake. Hello. Thank you very much for the very nice keynote.
Oh,
and a great program, Philip. Yeah.
Yeah. So it's great honor to invite Martin and Tim, who is a PhD. Are you a PhD candidate right now, or you're teaching?
No, I'm an associate professor. Sorry.
Associate professor. Okay, sorry for that. Yeah. Associate professor and teaching CETA. We have very often connection with Meta Thompson. And she actually gave a fantastic lecture, introduce your CETA, what your CETA doing in the past, over the past few years. I think it's a great lecture. And also we invite her to be the fellow of DigitalFUTURES. So I think CETA right now play a very important roles globally, and not only in Denmark, also I think in the future, including the future Architect Society conference will be coming. So, well, it's a great honor to have Professor Martin here. So the screen is yours. Please host the session 3. Welcome.
Thank you very much, Philip, and hello everybody from session 4, 3, and everybody else listening here. It's a great honor to share the session. It's really interesting. It's also, I would say, like if you know CETA, we're a relatively small team, been around for a long time, and we've been always working a lot with on different topics. So I think our remit is like that we look into more general topics and then dive deep in certain areas. And one large aspect of our work has always been on behavior and understanding interaction and perception through behavior. And like there's what Meta has probably shown a lot is like behavior on material and system level, but we also have been dealing a lot with behavior on human scale and humans. And so in 2015, we dedicated like a conference to this topic. So similar to the one today, like it's called Design Modeling Symposium. We made a nice book called Modeling Behaviors. And in there, we kind of tried to figure out what are kind of the different aspects of behavior and designing of behavior. And I think that's like, and they're going from like the behavior of like material systems, structures, but also to behaviors on human and urban scale. And I think this kind of range of design like is also very present in this session 3 here, where I've read with great interest a wider diverse range of papers that we're going to present. I'm very happy that all presenters are present here, and we have around 2 hours. Philip, say if I'm wrong, right? So until 5 o'clock or 5:15 your time, and I think we will go through that. We have like around 10 to 12 minutes of presentation, and then have like directly questions from the audience and from us for each of the questions. So I think we should start already a little bit beyond schedule here. I welcome Giulia, Bjorn, Ingrid, Paoletti, and Skylar Tibbits for their paper for the soft material, which is like a collaboration between like MIT and the Politecnico di Milano. So who's presenting? Giulia? Nice to meet you.
Hi, nice to meet you.
Hello.
Hi, Martin. Good morning and good afternoon for the others. So I will share my presentation. Okay. Can you see it?
Thank you. Very good.
Okay. Thanks. So today I will present for the soft material system, and as I said, it's a collaboration between Politecnico di Milano and MIT, thanks to ROCA research grants. My colleagues are Bjorn Sparrman, Ingrid, Paoletti, and Skylar Tibbits, and it's a collaboration again between Material Balance Research Group from Politecnico di Milano and Self-Assembly Lab from MIT. Okay, so I'd like to start with a paradigm of the dance of agency that has been introduced by scientist and philosopher Ludwig Fleck, which is the dance of human and non-human agency, in which the researcher and matter are both the active part and the passive part of this dance. As the active part of the researcher deals with setting up the material assemblage, and the passive part consists in observing what material will do and how they will perform. So those phases are then repeated in a loop, and that's why he introduced this idea of the dance of human and non-human agency. So material is nowadays then perceived as the active generator of architecture. So through material engineering, we can understand and know the genetic heritage of materials. And through computational design, we can embed data in material systems. Digital fabrication, again, is no more conceived just as a brute force or a mean of automation, but is the tool that can express material agency. Among these tools, 4D printing is the one that exploits programmable matter as a material whose properties can be programmed. It can be defined as 3D printing with the addition of time. So current state of the art in 4D printing includes it presents some challenges, has high-end multi-material printers, such as the Stratasys one, and then the printers company have their own proprietary material, so that we don't have much information about those materials, or researchers make their own custom lab engineered material. This led to the fact that the experimentation on active material is difficult for designers to access and to scale toward applications. We decided to employ rapid liquid printing as a tool, which entails physically drawing three-dimensional gel suspension. Therefore, it allows faster large-scale fabrication. Our aim was to combine the properties of rapid liquid printing together with the properties of 4D printing. So we have the possibility to print industrial grade materials from a medium to a large scale with a fast process. And we have a freedom of tool because we can customize them with the advantages of 4D printing. So multi-material printing with a programmed actuation and the possibility of having material customization. Therefore, we could have full control and customization of the whole process. So we started with silicon as the main material because silicon has this as a wide flexibility in terms of material properties, and then it was widely available. Therefore, from the fabrication point of view, we had constraints coming from the tank dimension. So as you've seen, the printing process includes a tank with a gel, and the constraints of the design for additive manufacturing from a design side. We decided to print shape-shifting silicon material system. So the aim of the project was to create these responsive material systems. And we were able to tackle this problem by exploiting silicon bilayers. So we were using 2 layers with different materials, so with different properties that upon actuation will cause a stress mismatch, therefore a bending in the material. We wanted to have both an active response and a passive response. So we investigated 2 material systems. One was achieved by using ethanol as the active material, let's say, and the other ones by using polyvinyl siloxane. And we will see shortly how these systems work. So ethanol, coming to ethanol, we can say that it's a phase-changing material. Therefore, the 2 layers that you can see on the right side are one made of plain silicon, and the other one was a mixture of silicon and ethanol. Ethanol, while undergoing the phase change from liquid to vapor, expands, and this causes the bending. We were able then to generate this active responsive material system. We printed this star-like aperture. We were tuning all the material properties. I've put here a table just to let you understand. These are the percentages in weight, but just to let you understand which parameters we had to keep in mind. And of course, as you can see, the design was optimized for the machine, so for additive manufacturing. And we had to keep in mind also the material properties, such as the viscosity and the thixotropy of the gel. So we had to push one layer on top of the other more than the layer height that we were supposed to have in the end, just to ensure adhesion. So the result was a thermally actuated star-like aperture. Here you can see it's actuated through a heat gun. This is why it's moving a bit in a weird way. So the layer with ethanol expands and causes this movement. Regarding the other project, we have been investigating swelling rubbers. As I said, using these polyvinyl siloxane bilayers materials. This research has been actually started from the Moss lab at Boston University, as they found out that these two materials react because of the chemical bonding that they have inside their internal forces. So following the Timoshenko bimetal model, we were able to understand how the curvature was changing by tuning the properties of the overall thickness and the relative thickness of one layer in respect to another. So these ones are the custom samples. And then we were able to print them. As you can see here, there are the two materials, the green and the pink one, and they have different shear hardnesses as well. So we found out that the ratio of 2.5 of the green over the pink layer thickness was the one that was causing, let's say, the most dramatic bending. On the other side, we were able to exploit the properties of the silicone printing. So the fact that it's a liquid and that we can actually print in one material inside another one. So in the same print, as you can see in the left image below, we were able to have two different curvature, to achieve two different curvature in one piece. And these are other printed samples that show the different printing strategies. So on the left part, on the bottom, on the top, you can see, for instance, that the circle has inside, it's really barely visible, but has inside a spiral printed with the pink material, while on the other side, on the right, we have stripes. So these are different printing strategies to generate bending. We also employed this kind of lattice structure in order to constrain this movement and see what would happen and how much dense they would have had to be in order to constrain the movement, what happens when we remove them, and so on. And the latter on the right side is a morphable fur, as the printed pattern that you see here in pink generates a change on the surface on the other side of the fur. So this was also another nice outcome. In conclusion, we can say that our main research questions were which silicon-based materials could be used to achieve shape shifting. And we found that both the silicon ethanol mixture and the polyvinyl siloxane bilayers have proven to be feasible. And on the other side, which design strategies and fabrication procedures were needed to create a responsive system? Well, we found out that actually there were some challenges, such as the silicon porosity combined with the volatility of ethanol, which jeopardized the durability of the system. There are ways of, I mean, there have been researchers that have tried to avoid these, this issue, but still it's a work in progress. And on the other side, the polyvalent silicon bilayers are not reversible once actuated. So this was another challenge. But in the end, we could say that the these soft material system have proven to enable a wide array of kinetic solutions. Thank you.
Thank you, Giulia. Really nice. Nice experiment. Looks super interesting. I want to ask everybody, if you have some questions here from the audience, and use the question and answer box here just to ask like our panelists here any question. Appreciate it. I will just kick off here, and I think it's really interesting. And that's like, Giulia, I think what your system, the systems you're working with, is a bit like bi-material systems, right? So you have like two different materials, and one shrinks more than the others, and then this creates a movement. Is this the underlying mechanism that you're using, right?
Yeah,
like
the basic mechanism is that one. On one side, we have the silicon and silicon plus ethanol, which is a bilayer. So we have one that is just silicon, which we can say is a passive layer, and the other one, which is the silicon with the ethanol, that it could be actuated through heat. So when it's heated, it undergoes the phase changing. It has to be heated up to 70 degrees. But there are, again, ways to Celsius, but still there are ways to improve the thermal conductivity of the silicon by using some additives. And this makes it interesting if we think about apertures that can be actuated by environmental stimuli. So when it's heated by the solar heat, it can open or close as a system.
Yeah. That was my question, because like then you add actually ethanol, like something which is like easily evaporating into the mix, right? So that's like the second layer is like an ethanol, and then you also said like it's something about durability, etc. So then this is because the ethanol is evaporating, and then it's gone, and then your silicon with ethanol mix becomes in the end silicon again,
actually,
or how is it? Like?
It actually doesn't evaporate all. So it becomes vapor, but it remains trapped as bubbles. Okay, it remains trapped in the silicon mixture. So it won't evaporate immediately. There is an issue with durability, because what we have seen is that after 30 cycles, the specimens would not behave the same anymore. So the result of the shape shifting wouldn't look the same. So in order to avoid this, what can be done is to try to encapsulate the layer with the ethanol deeper in the mixture. So as in the specimen that I've seen that I've shown with the double curvature, we were able to put the material the same side, and another material it's kind of encapsulated. So with that strategy, it is possible to make it more durable.
Okay, but you probably will always face the challenge of diffusion, right? So like that, similar, like if you have a balloon with helium, then the helium will diffuse through the kind of rubber at some point.
The thing is that exactly silicon is porous, so that could be a challenge. What they do in soft robotics when they use these systems is that they actually cover them, so they coat completely the system. So that could be another option, to coat it with another material again. But yeah, we were still in the phase of seeing if we could actually rely just on these two materials.
Okay. No, really nice. I think like there first, Philip, your question.
Probably here is a question from Bilibili platform, and asking about the scale, because no matter 3D or you mentioned 4D printing, scale matters. So what's your research vision? Right now, maybe it's a small scale research on the true material performance. You're write this paper. What's about your future plan? Would you like to enlarge this to some bigger scale, a macro scale project?
Sure. Thanks for the question. That's a really good one. It's a really good point because scale is one of the biggest issues in 4D printing. First of all, because of the machine size. So the largest printer is never big enough, no? But with this system, we were able to tackle that problem because you need a tank with a gel, and it can be done, if you think about a swimming pool, it can be done inside of a swimming pool and you can print inside it with a robotic arm. So in that case, you wouldn't have the problem of the scale. The problem of the scale comes at a material level because the material system just doesn't scale up in the same way. It doesn't work in the same way when you scale it up. So these prototypes were all of the in the order of 20 centimeters, like the biggest one was 20 centimeters, which could be enough for a small component if you think about like a small shading system or a singular shading or a packaging or some adaptive wearables. So in some domain, they could be already, let's say, ready for production, for the market to be used. But on the other side, if we think about a building system, there's still much to investigate in order to understand how to scale up the behavior of the material system.
Good. Thank you very much. Yeah. And like silicone also, it's not necessarily super UV resistant, etc. So, but I think it's really cool that you're doing this research, and like I think I had more, maybe like we will have more similar projects over today, and maybe in the wrapping up session we can discuss like questions of design, interaction, and simulation, etc. Thank you. Super. Should we go on to the next, Philip?
Yes,
Thank
please.
you so much.
Thank you
very much. Okay, now we have paper Material Response Technology, Material System Responsive Design by Macruz, Farr, and Andrea. Macruz, you are presenting here.
Yes, hi, Martin.
Hi. So everybody, for the collaboration between Shiner, Chongji University and Sao Paulo, is it right, Macruz? Andrea?
Yeah, Andrea and I are both with Chongji. We're PhD students with Digital Futures. Andrea is in Sao Paulo, Brazil, and I'm in the United States, actually right now. Usually in the Middle East, but now I'm in the United States. So Andrea and I will both be presenting the paper.
Cool. Great. Thank you very much. The stage is all yours.
Thank you. Andrea, are you here?
Yeah.
Andrea, can you hear us?
Or Andrea, like we cannot hear you, so I think there's something with your microphone.
Yeah, I think Andrea, maybe, I don't hear Andrea?
I think to reconnect. Marcus, maybe you start, and then Andrea will most probably pop in, and then we take it from there. Is that okay?
Yeah, we can try to do that. I know that she was here and she has the privileges to speak, so she should be able to hear. I just messaged her and she's not there, so we can go ahead and get started. Anyway, this is, my name is Marcus Farr. I'm here with Andrea Macruz. We're both PhD students at Chongji University, and our paper is called Material Response Technology, Material Systems and Responsive Design. Really, the project investigates the role that technology and neuroscience play in making meaningful connections between people, architectural space and furniture, and discusses why it's important to focus on designing with more significant impact, focusing on the quality of experience rather than the quantity of objects. And to interrogate that further, we created a series of simulations based on a piece of interactive furniture as a centerpiece to an architectural space. Utilizes a computational pattern that is coded to respond to human activity and is then connected to a computer code that makes readings based on human interaction. Here you're seeing a Houdini model.
Marcus, can you hear me now?
Yeah, I can hear you, Andrea.
Yes.
Okay, perfect.
Great, welcome. Yeah, I can hear you now.
Thank you. Perfect. So let me pick on here.
Cool.
I
And
don't
then
know
you
what
already just
happened.
said that we would start, and then you would like shift this Marcos, like when you're back
Yes,
in. Great that you're in
perfect.
together. Yeah.
Okay. Okay, so I think you can continue.
Yeah, so today there are numerous technological tools that connect people with one another. Isolation and polarization are becoming more and more common in the everyday life of people. And our original questions were, is there a way that technology can help us to strengthen verbal and nonverbal communication rather than create isolation? In other words, can we use technology to humanize humans? And so when we were exploring concepts for this project, we were discussing communication in the following ways. If communication is about feelings and attitudes, and words account for only 7% of the total message that people receive, then the aim of the project could be to improve verbal and nonverbal communication between people through technology.
Yes, in an age where technology and screen-based interaction continuously surround us, a physical, sensorial approach provides new experience. So it's very important that immersive physical experience coexist and are balanced with digital ones. And this allows us to re-engage with the world in a new manner, emphasizing the positive aspects of technology and reducing the bad ones, such as depression, FOMO, etc.
Verbal communication coexists alongside nonverbal, which can affect our perception. And the ability to communicate nonverbally can be improved by paying closer attention to other people's unspoken behaviors, such as eye contact and the movement of the body.
Yes, so being aware of what we say and how we say it and our body language is the first step to a successful communication. And this project helps to facilitate this by bridging human sensorium with verbal and nonverbal communication.
The neuroscientists are continuously exploring the connection between the brain and the sensorial channels through which we understand and perceive our world. And designers are exploring sensorial channels to build an emotional connection between the product and between the user.
And according to Andy Clark, it is not enough to say that the mind is contained only within the boundaries of our brain, because it has always collaborated with external non-biological sources to solve better the problems of survival and reproduction of humans. So the separation between the mind, body, and the environment are not seen as distinction.
And so with these theoretical ideas in mind, the paper explores the potential design contribution that can come from a process that uses computational logic and new media as the tools for prediction. And this process of simulation also aids in creating a more robust physical prototype for us. In the project diagram here, we annotate the physical and the invisible parts of the project, including the sensorial boundaries that are thought of when designing the project, and the possible gradients of both man-made and human activities such as Wi-Fi, the sensorium, technological, and also human, temperature, along with the scale of the project, and the material relative to humans at the time of interaction with the project.
So using digital tools such as microcontrollers, Rhino, Grasshopper, and Houdini, and paired with physical testing, it interrogates a workflow between computational design, production methods, and material logics, trying to simulate a person's state of being, excited, calm, etc., is difficult when making a physical model, but much easier and much more accessible when doing a series of design computations, design models.
Yeah. So moving further into the process, we used a Houdini model to explore how color could be simulated based on information that's gained from our UpMood algorithm. And then also in collaboration with that, a typical kind of Rhino model to explore the visual capacity for the different material states, such as the changes in physical composition as a result, and the differences in temperature that would come from the algorithm.
Yeah, and the results here range from a one-person interaction to a group of interactions and offers insight into how this project could work at a large scale in the build environment. So the methodology associated with this project offers immense speculations for the future projects. And we felt that in some ways, designing the process was more important than designing the finished product.
So part of that discussion included the logic for the shape of the, what we're calling the leaves of the project and how this could inform the overall surface pattern. In this image, the leaves are on a tree are actually different and have different performative values. So for example, sun leaves are comparatively smaller with a more jagged edge condition. This gives them smaller surface area and the wind would flow through the leaves more easily. Shade leaves, on the other hand, which you're seeing here in the image and the diagram, are bigger with the less jagged edge condition, which allows for more absorbing of energy.
And the initial sketches and study for material explored shape grammars of leaves and how the shapes worked with bending when heated. So decisions were made regarding the performance quality of the leaf shapes. We chose alternatives that were sun leaves and some as shadow leaves.
Yeah. So this was a process that was further explored by testing and developing these leaf patterns, and ultimately deciding on one leaf profile that behaved with the most consistency, and then grouping that into a composition that could respond to people in the right size and related patterns. So there were several patterns that we went through in the process of the project, and it's not by chance that the better performing leaves were the sun leaves, because their shape was more responsive.
And as we began researching and manufacture our own material combinations, it became clear that an extremely thin metal combined with special thickness of paper was the most successful for the project. So the metal allowed for enough rigidity, and the paper material allowed for a more direct relationship between the thermochromic paint and the temperature differences.
Yep. These are the electrical resistance coils were used in the testing process of the project. There's a range of shapes and power options here available for these that we tested. Ultimately, the one that we used had a thermostat that varied on the low side from 600 watts and on the max side to 1800 watts. The studies that came out of it indicated that 500 watts of potency was enough to achieve our desired outcome with the biomaterial that we were using.
Yes, because at 500 watts, the biomaterial bends. So the higher the temperature, the more the metal deforms and the more it's responsive. And the activation temperature for the thermochromic paint is 30 degrees Celsius. So the decision was made to utilize the morphologies that bended best with the heat.
So the project also incorporates a leuco dye, which is a water-based thermochromic ink. And with this as a coating, the colors can change in the presence of the temperature variation. So the process is reversible. We found up to 60 degrees and irreversible from 60 degrees onward. We found also that the leuco dyes for this process are available for temperature ranges from 23 degrees Fahrenheit or -5 degrees Celsius to about 60 degrees Celsius or 140 degrees Fahrenheit.
Yeah, and this culminates into a system where a user can interact with the sealing. The dye, the temperature, and the beam material begin working together with the processing technology to give a sense of synergy between human and surface.
Yeah. So in order to predict the overlap between the architectural and the sensorial and the augmented, we worked with UpMood technologies with this project to begin to understand how to measure and estimate how people could feel or respond to a given environment, since that was a big part of it. Here we can see the UpMood wearable technology as a wristband. Each band is equipped with a sensor that measures the wearer's heart activity. And so users wore these bracelets when they visited our project.
And this allows us to collect biodata from the user and result in 11 different emotional states, such as calm, pleasant, happy, excited, etc. And this data was continuously fed into an app that began translating the sealing pattern. And the use of these overlapping technologies acted as a way to gain insight into a more profound human experience.
The sensor for each band works directly with the sealing. And so as shown in the diagram here, the process that we developed with the project moves through a QR code to an iPhone and then reaches the UpMood app and an UpMood wearable sensor and processor, and then programming then to the table, to the sealing of the project, where the material responds accordingly to what the user is feeling in that particular moment. And the hardware consists of a heating element shown here, a microprocessor, which is connected to Wi-Fi, and a relay module with LCD display. And in addition to other auxiliary components. To receive the information, the microprocessor, which is an expressive microprocessor, can be connected to the internet with a Wi-Fi network and used to communicate directly with our UpMood server. And once emotions are received from the server by the microprocessor, they're shown on the display directly, and then the heating element is activated or deactivated by the relay module, and that's reflected in the project.
So here we are seeing the testing setup. I think we have to turn on the videos that puts this technology into play. In your testing, the prototype changes its behavior according to the emotions captured by UpMood bracelet, reacting to two possible states, being calm, that is the upper one, and aroused. I think we can go.
So the entire process happens automatically, and as long as the system is connected to the internet, the app is receiving data from the bracelet and sending it back to the server. The project reacts to the emotions of whomever is using it based on the biodata that's collected.
Yes, so this work documents the process of a furniture project that was designed to induce a sensory experience. It explored this concept relative to digital design and material interaction in the field of biomaterial, thermal properties, and the human sensorium.
Yeah, it also incorporated this potential by capitalizing on the role of material manipulation and respond to temperature as a way to interact with architectural space and people. And the outcomes imply that through the research and the design, the stronger sensorial experiences can be used to increase awareness and perception and create new design conversations. So thanks very much. We're happy to discuss this project further.
Thank you very much, Macruz, Andrea. Really nice. I think you're a great designer. So to say, when I read the paper, I really like your design. It's very kind of simple, if you want, but like also kind of evocative in how it is represented. And I think it's a interesting, like, say, inspiration of being interested in the fields, right? Like this, what you did with Houdini, and then translating it into kind of a biomaterial system interactively. And I also think that your addition to the shape changing world, like the biomaterial world with this color coding, is really nice. And so I think like the heat active color on those is really nice material finding, I have to say. So congrats on that. I think that if you look a bit further, then you will find that there are quite a lot of people who, for instance, like put in conductive wire, etc., into those leaves so that they move without having a 500 watt heat source underneath. So your infrared grill on top of a conference table is probably a bit intrusive from what you want to do. I think you can go with really a lot or less of wattage there. I think that's fine. Like, there's probably the technical aspect. I'm really, as you're both PhD candidates, more actually interested in the one question or so that we have time here for, is more in your attitudes towards this what is the social setting of something like this? Because you've been rightly saying that like people have different ways of communication. There's verbal communication, but there's also non-verbal communication. So we're very active in reading each other's feelings, right? So even when I just raise my eyebrows or get big eyes or whatever, or start to sweat or so on. So all of this are kind of like, all of this is kind of happening, and you understand this, right? So like this question, like what is this, what you're doing there for? So what is like helping there? Sorry, my kid is crying in the background here.
Yes, I think facial recognition, it's something that is really nowadays being discussed because it depends on culture. So the problem is, if you have different cultures, people have different, show different kind of emotions. So it's not something that per se can be analyzed. And when you link that to a biodata, it's always a parameter more than you can put in the equation. I think basically is that. And also for the future, we wanted to use graphene. So it's not going, we did the test with resistance, but we are looking for new technology to use graphene or something that could be really light and could do this energy transfer flow in a kind of a different way.
Yeah, but I think like when you say like this, so Macruz.
Yeah, just to add, we were really interested in a kind of material response that could take place, and throughout the course of the project, of course, this was happening in a pre-COVID-19 environment, and then also became part of the COVID-19 environment. And so also kind of seeing this as something that could be useful as a way to become a communication tool between people that are separated by distance, and also something that could become scalar, the scale of an office, for example, the scale of an architectural space. It could become not one project, but let's say 3 projects to accommodate a group of people. Could also work. We've had dialogues about a park setting and things like this, where COVID-19, obviously people want to interact with people, but the distance is a big part of that. And so this is also kind of something that we've been talking about with this project.
Yeah, I think like in an art setting, I would really like your project. Just saying, like, because it reminds me a little bit of a very positivistic attitude. And like maybe if you read like No Foucault or so, the question about the French philosopher, or question of control and power and so on, then this is a very revealing thing. So it's very like goes really deep into your privacy. And so maybe if you're not a poker player, then it's okay. But if you're a poker player, then you really don't want to show everybody what you're thinking, or if you're negotiating or so on. So I wonder, what are the layers like in there? Or maybe these are questions that I didn't really find addressed in your paper. Maybe like this really underlying questions of like why and how and when would you like to express this level of feelings to others? No? So but it's a kind of void of this more societal or questions, then I think it's a really nice piece of work, and I hope to see that you kind of get it from, say, probe status into a real like installation. So Philip, all right. I think we should like move forward because we're already a bit over time here, and I guess Philip wants to go through the project. Okay, thank you. So I now like welcome like Sijia from the third paper called Diversifying Emotional Experience by Layered Interfaces and Affective Interactive Installations. Sijia, you have been here before. And,
can you hear me?
Yeah, we can hear you well.
Okay, thank you, Martin. Thank you, Philip.
Thank you, Macruz. Good luck.
Thank you. Great job.
Hi, Sijia. So Sijia is also from Tongji University. Oh. So you're from Zhejiang University and you're presenting your paper, which you've written with others from your university. Hello, your stage is yours.
Okay. Hello, everyone. My name is Gustavo, a fourth-year graduate architecture student from Zhejiang University, and I'm going to present a work of our team. This case-based research aims to improve users' experience in effective interactive installations through the diversification of interfaces. We attempted to layer the data and different models of interactions in order to logically organize hierarchical experience and thus provide a more engaging atmosphere to create more immersive experience for users to interact with installations. And here is a little bit about the background of the research. Effective interactive installations become an exploratory field with the development of emotion recognition technology. The boom of effective interactions has in turn called for the increase of diversification of interfaces. Effective interactive installations with unimodal interfaces have already proactively contributed to explore the potential of interactivity. However, a unimodal interface limits the composition of a multi-layered interaction, which plays an important role in interactive installations. And the research from L. Mignano and C. Sijia, which we took as the basis of our experiment, indicates that a multi-layered interaction could arise users' engagement with installations which develops through the interactive process. And here in their theory, according to their theory, to provide an immersive experience for users in effective interactive installations, the diversification of interfaces could be said to complete the four threads, which are compositional thread, spatial temporal thread, sensual thread, and emotional thread. And we propose that the compositional thread can be constructed by advancing the depth of interaction. The spatial temporal thread can be strengthened by mobilizing an engaging atmosphere and creating a mentally or enveloping environment. The experience for sensual thread and emotional thread can be enriched by creating an engaging atmosphere through the architecture of physical space. And here is how we interpret, and adapt the hypothesis. The diversification of interfaces drives from two aspects. For input data, enriching the source increases its diversity, and performing multi-dimensional analysis to deposing existing data could also be a variable way. For output media, adding diverse actuators to the installation and increase the possibility of their actions leads to dynamic behaviors of the installation, thus making the experience richer. And accordingly, we set a reaction mechanism to create smooth and dynamic behaviors of the installation, which are supposed to take on different forms in response for different mood states of users. An organic form is chosen to apply on the installation. Diverse input data and output media are deployed in the installation. Multidimensional data are collected by sensors and analyzed by an emotional recognition system, and directed to actuators as outputs, which perform a variety of actions to respond for different human behaviors. The actions are iterated to be a logically organized hierarchical experience. A typical interaction experience process includes 4 parts according to the depth of interaction. Here, the installation is weakened, the user's emotions are reflected, the user's emotions are constantly exchanged, and the user stops interaction. And based on the mechanism, we made a prototype. In order to create a mentally or enveloping environment and highlight the interactivity of the installation, the overall structure should create an immersive atmosphere while also becoming one of the emotional inputs of the users. Thus, a form where the emerging and disappearing spheres distributed in the space is created. And the overall installation is composed of 4 parts containing the sports structure here and the transparent glass bodies M1, the frosted glass bodies M2, and the mechanic flowers. Among the flowers, those directly placed on the structure M3 are interactive. The support structure serves as a carrier for other components. M1 are transparent glass bodies, which contains mechanic flowers used to express the other 6 emotions. M2 are frosted glass bodies in which mechanic flowers that serve as light fixtures are contained. M3 are interactive mechanic flowers placed directly on the structure, which are used to express one's dominant emotion. Through the arrangement of the glass body, interactive mechanic flowers are distinguished from others. 7 mechanic flowers are installed as interactive group corresponding to 7 types of emotions. 5 sets of mechanic flowers are placed to provide interactive experience for multiple people. To achieve the process of emotional interaction, we used in order to create an engaging atmosphere through the decoration of the physical space. Actuators of the installation are designed as mechanic flowers, just as these drawings. And to achieve the process of emotional interaction, we used camera and freight sensors to capture data and program in Arduino and Python as control system, and servo and step motor are connected to mechanic flowers as actuators. A typical experimental sequence will be divided into 4 parts. First, the installation is weakened. We use an infrared sensors to detect the distance between the user and the mechanic flower so that we know when to start the interaction. The program in Arduino IDE will enable the servo on mechanic flowers that present emotion of users to rotate or open. Secondly, the user's emotions are reflected. With the pedals open, the camera will be activated and transmitted the image of user's face to an emotional recognition program in HiCharm. which will output 7 representative emotions percentage in the imaging. The data are sent to the Arduino IDE, in which the program controls mechanic flowers to take actions. The actions of mechanic flowers include glowing, rotating, and blinking. For the action of glowing, it is applied to 7 mechanic flowers, corresponding to 7 motions. We set 7 colors of RGB LEDs, also just like this. Here, we set 7 colors of RGB LEDs, which are placed in mechanic flowers. Here are some photos of our testing process. In addition, we set the brightness of LEDs according to the percentage of motion. For the action of rotating and blinking, it is only applied to the mechanic flowers that presents document motion. Thirdly, the user's emotions are constantly exchanged. When the user notices the actions of the flower, his mood may change. The changed emotions will be captured again and reported to the program. Thus, changing the actions of mechanic flowers and the diverse actions of mechanic flowers could stimulate users' moods in a multi-dimensional way, which makes the interactive process more playful and more desirable. In this way, users and the installation make a continuous exchange. Finally, the user stops interacting. When the user leaves the installation, if the freight sensor is unable to detect the existence of objects and lasts 15 minutes without detection signal, the interrupt will stop. And in order to verify whether diversified interfaces are indeed helpful to improve users' experience, we conducted an evaluation experience through VR to experience the installation with 2 different interaction settings. In the first setting, we make the prototype to recognize emotions type and turn the data of types into different colors of RGB LEDs. And in the second setting, we detected people's location and the petals would open or close. In this setting, we also detected emotions type and percentages, and we get different actions of mechanic flowers. And after 5 minutes of interacting with installation subjects are interviewed, 10 out of 12 among them did agree that the progressive experience is more attractive. The rich feedback makes them more immersed in it, and the diverse experience of flowers makes them more interested in changing facial expressions to observe their changes. In addition, in the experiment, we noticed that after a series of interactions, 75% of the subjects' facial experiences gradually tend to be happy. That means we achieved two-way feedback and influence between users and installations. And the presented research is a coursework from the introduction to computational design course at Zhejiang University during our online semester due to COVID. So unfortunately, we are failed to test the installation at full scale. With the possibility to convene offline, we are in the process of improving the experience and fabricating the project for further research. Finally, thank you for the team members participating in this research. They are Yuwei, Jiale, Huang, and our advisor Weishun, and thank you for listening. Please be free to ask questions. Okay, here are my questions.
Thank you, Sijia. Like you timed very well to exactly 15 minutes, so we have very little time for questions. So thanks for your your paper really interesting. I mean, I'm just saying that the paper is really interesting, very complex question that you have, like a very deep, like a lot of levels, etc. And I think in your paper you're very could be a bit deeper even, I find. So there's a lot of description and like not so much information about the setup of your VR testing. It's like in the end of the day, you want to have like the interaction of your apparatus with a human, right? So, and I find like that your paper is mainly about the apparatus and very little about the interaction with the human. But saying this, and there's also the whole COVID situation, etc. And I think like what I found interesting is that you have done this VR experiment, and maybe that's interesting because like we all know that making those installations and Arduinos and feedback and so on in a physical environment and doing testing of this is really a lot of work. And most of the time you're there fixing hardware and not fixing interaction actually. And so I wonder, just this one question that I have, like, how is your experience with the VR experiment? Do you think that there can be a surrogate or replacement of like a physical testing? Are the results are like positive?
I think VR will be a good tool, but it can't replace the physical model because they still have some differences. For example, when we do our VR test, we found that there is some perspective problems in it, and we can't experience the installation in a more natural way. So I think if we can make physical models, it is necessary for us to make physical models.
Okay. Okay, so you would rather make physical models than like VR in the future?
Yeah, and I think the development of VR model will be an interesting aspect for us to development.
Yeah. Cool. Thank you. Thank you very much, Giulia. I think in interest of time, we need to move forward to the fifth paper by Weishun and Wenjing. I don't know who is presenting of you today here.
Hello, can you hear me?
Hi, Wenjing. Hello.
Hi.
Hello.
Yes.
Thank you,
I will
Sijia.
present.
Hi, great.
And I will share my
present
screen.
your work subjectively measured. Yes, please. And you have like a very international team, and would be nice to hear a little bit about your collaboration as well, maybe in the introduction, like who you are, how you come together in this project. Yeah. Thank you very much.
Okay.
So,
I will share my screen. Is it clear?
yes, perfect. Very good. Thank you.
Okay. Hello, I'm Li Wenjing from the University of Tokyo Center for Spatial Information Science. And the title of our research is Objectively Measure Strip Scale Qualities for Shanghai with Large-Scale Application of Computer Vision and Machine Learning. Different from the previous presentation, which focused on the maybe the large-scale installation. Our research is focused on the human perception in large scale. And this research is part of the output of the workshop that our team holds in last year's Digital Futures. And here's the short introduction. Recently, with prevalence of street view images data in environmental auditing, computer vision have been widely applied to extract streetscape features, making the large-scale urban scene understanding possible. Current studies are limited to the objective measure field study have adjusted subjective measure effectives in capturing more subtle perceptions using street view images data. Maybe many current study only analyze the view index of individual features such as tree and building, while the viewer's overall perceptions are ignored. Human perceptions have subtle relationships which cannot be fully represented by individual view or a simple combination of them. subjective measure can explain more human behavior and capture more subtle relationship. It is more user-centered. So, and as for subjective measure in streetscape related research, they usually collected from survey or interview, which is costly and difficult to apply to large-scale region. So to bridge the gap, we took Shanghai as an example and applied CV and machine learning to subjectively measure for perceptual qualities, the enclosure, human scale, capacity, and imaginability. We also conduct a core study for global cities. Urban renewal implications are derived for policymakers based on the global comparison. In this research, we analyzed more than 100,000 street view images from Baidu API and applied 10 machine learning and 2 computer vision algorithms in the study, subjectively measure for perceptual quality score, and of course study 6 leading cities in the global. And the study area is Pudong district in Shanghai, and the data we use include street view images and POI data from 大众点评 and AutoNavi map, and also the shapefile from OpenStreetMap. And this is the workflow. We collect thousands of street view images from Baidu API and randomly selected 300 of the images. Architectural aspects are asked to evaluate the street quality per sections of 300 images. We can also obtain the physical features by applying computer vision to the images. Then we can train the machine learning model based on the subjective score and the physical features of those 300 images, and use this model to predict the subjective score of the total street view images. We also conduct the core study of the subjective score for global cities. Here is the definition of the street view quality score we evaluated in this research. They are from the literature review. And enclosure refers to the degree to which street canals are visually enclosed. And human scale refers to size, textures, and articulation of physical elements that match the size and proportions of human. Capacity refers to the visual richness of the space, which depends on the varieties of the numbers and types of visual element. And imaginability refers to the qualities that make the streetscape distinct, recognizable, and memorable. And I will introduce the detail of our methodology. First, we download street view images with constant angle and requirement every 50 meters. And we randomly select 300 images across Shanghai region as a training data set. To collect people's preference on street things as the training label, we develop an online questionnaire platform where people can select the image they prefer in pairwise comparison regarding their 4 perceptual qualities. In average, an image was compared to 10 other images, which is efficient enough to let the results coverage. And this preference will translate to ranking score by applying Microsoft Choose scale algorithm and normalize into 0 to 10 scale. And this is the example of the high score images and low score images. We use a PSP-NAP to extract and calculate the pixel ratio of individual feature as view index from street view images. We also apply Mars RCN to count the amount of car, people, sites, and street furniture. Now we have subjective score, and we also have the physical features from the street view images. We can train the machine learning model. Here is the training data set summary, and we apply multiple algorithms such as KNN and support SVM and random forest to predict the full perception score. And MAE was set as the loss function. We then apply the best performance model to all downloaded street view images and devise the full subjective score for Pudong area. And here we can see the street features which contribute to the perception score. And this slide shows the predicted result. The distribution of four perceptual qualities are heterogeneous. The downtown area, such as here, the Lujiazui, are highest. This result indicated that when considering allocated renewal resources, more could be invested in the residential area and industrial parts where street qualities are low, but with large residential population, and in polymer such as here, the Zhangjiang high-tech part. Meanwhile, we also conduct a regression analysis among four qualities to check their correlation. The result shows that the degree of immeasurability is significantly and positively correlated with enclosure and complexity. And we cross-reference complexity score to the POI density using such as food, restaurant, entertainment, and recreation. We found that the higher complexity score is correlated with more POI, and indicated that the predicted complexity scored will capture the impact of human amenities and service. And to validate our framework, we select a Zhangjiang area in Pudong and select 5 other innovative districts. Here we can see from USA, UK, and also China to do the comparison analysis. We want to find out what kind of environment can promote the urban innovation. And the perception score of Zhangjiang high-tech parts are compared to that of 5 other benchmarks. And here is the result. We can find that the Pudong streets quality fall behind global best practice. Zhangjiang has the lowest average score compared to 5 other best practice. It indicated that more urban design implementation could be considered to improve the overall quality of street environment, as the good street environment can promote innovation. And secondly, we can find that the 5 other global districts have similar variance in score, while the score in Zhangjiang are highly polarized. It means that its development is uneven. And maybe the future study can conduct to investigate whether such uneven distribution have posed incredible issue to specific population segments. And to promote the actionable policy suggestions, we cross-reference perception scores with objective metrics of urban urban form and density, such as the average box size and floor area ratio. And we found that Zhangjiang has the widest row, but the lowest density measure, which explains its lowest perceived enclosure. Since lower building height and a wider strip lead to less enclosure, and a less enclosure would limit the neighborhood walkability and result in less working behavior. It can be confirmed by the pedestrian counts from street view images. And in conclusion, in our research, the cross-study of 6 global urban counts include Pudong districts confirm the generalizability of our proposed framework, and the subjective measure capture more comprehensive and subtle human perceptions than using individual view index. Although measured from simple images, perceptual score can capture many urban space quality and characteristic of urban metrics. For example, the street-wise, building-wise, block size, and amenity density. And our framework can stand alone without any license, program, and software. All information needed are open source. So our proposed framework is more accessible and higher throughput. And the cross-study indicates that the polarized and uneven urban development in Pudong district. Also, there's maybe the limitation. First, our segment only use pre-trained model. Future study could train specific model to cover more tasks, such as to reject the facade and window, which significantly affect many human perception. And secondly, our training data is limited by the amount of volunteer, and volunteers are not randomly selected. And third, further investigation can be done to adjust the invergence and coherence between subjective and objective measure of urban perception. And this is our future work. Okay, thank you very much. And this is our presentation.
Thank you, Wenjing. Really amazing work on data, like a big data here. I really congratulate you for this treat. You've been working on it quite long, I see. So like from starting in a workshop, so it's really nice that this is like a legacy of the last conference, like a DigitalFUTURES conference. So really cool. We have not much time for questions. Like if anybody here from the panelists or so has other questions, please use the Q&A button down below. Else, I think like it's, first of all, I find it super great that you have the data and like to do this. So I mean, here at CETA, we find that there's really too little data on architecture and urban spaces. So everybody's talking about it, but actually finding this data and like mining it is like a very rare, at least in like more design-oriented circles, I think. And so that's really great to have this kind of approach. Overall, I have to say for sure, you're as you also yourself say, you're very much biased, and you said you're kind of the people like the who voted or trained the model are kind of like not randomly selected, etc. and so forth. So like that's all very clear on this regard. So like the agents, like the design, the bias is clear. And there's a question also like, or mainly the main question I find is that right now you have like the technical part, say, not solved, but it seems to be like a worldwide available data source that you have that you can query now for your things. And then the question I have is then, so what is the underlying motors that you have? And here you have like 4 different pointers that you have like for the quality of it. But for sure, if you think it through, then what you create is kind of an average, right? So you kind of say, okay, this is like what this first group of persons like, and then we go through all the world, and you kind of let out that a lot of things like perception are very much based on your cultural uprising, etc. And somebody who comes from the Midwest of US will probably think of Pudong very differently than somebody who kind of grows up in Beijing and then comes to Pudong, etc. So like, I think this kind of like, for whom is it and what is it for is very much the question that I would have to use. So like, when you think of the future of this work, so what would be the use of it? Would it, like I said, would it be a rating tool? Would it be a design tool, which you kind of do pre-design, or is it something to kind of optimize a city afterwards, or to put some data on the city to kind of convince somebody to invest because it's obviously like linked on your data to bed, or what is kind of the idea here?
Yes, thank you for your comments, and I think it's a good question, because when we want to transfer this training model into other cities, there would be some problems, such as the people who participated in the vote, and I think maybe in the future we can add more people from different groups into the voting system, and to ask more people to join and to ask their perceptions of the streetscapes. I think it could be better for training that machine learning model, and it's our future work.
Mm-hmm. I mean, it has interesting complication with ideas of design, agency, etc. No? So like how does especially urban design come together? It's very different in very different parts of the world, where you have more top-down or bottom-up approaches and so on. But I think it's and maybe seen positively, it could be something to give more access to more people to design questions, rather than having like somebody in the administration or the master planner kind of to think about how design should be. So I think,
yeah,
so we have some more questions, or kind of Philip?
Yeah,
okay.
I think it's a very interesting team, because DigitalFuture give a special platform and asking different people meeting together, different background, and make a very interesting research. So keywords in your research is subjective measure. I think
yes.
that is really interesting, because when you select the data, you need to meet different people, and also got different feedback. So in order to find more like reasonable research, how would you like to address the, I mean, the structure of your data, and how would you like to structure your big data information in the future of this risk? Because right now it's like a bit too broad, I think, the topic, and as a paper, it's better to be more focused. It looks like more like a PhD thesis paper. It's a very big topic. So I want to know, how would you like to analyze this kind of a subjective measurement, and how to define this different to the objective measures? And what could you analyze a little bit on that?
First, here we only in this paper we only measure 4 subjective measurement score, and but in the but actually there are other perceptions such as the greenery and the ecologic, and maybe their connection and identifications, and such kind of perceptions can be applied into this system. And also because the environmental elements could have the impact of the human subjective measure. For example, the site-wise, the street-wise, and the relationship between the objective measurement and the subjective measurements are one of the questions that we are interested in. And also because different groups of people may have different subjective measurement, will have different subjective perception. For example, the perception from the old and from the young and from a student from the residential are different, and that would be the difference from the difference of different groups' perceptions would be another interesting questions. Yeah.
Yeah. Thank you very much, Ming. I think we need to move on. One thing, Philip, would be really nice to think about for the Digital Futures format is like, what is a paper? Because like in this paper, like what Beijing presented, there's a lot of data involved and also a lot of like machine learning, like data. So Beijing had in your presentation, you had some kind of like the assessment, for instance, like the table of like the assessment of your training outcomes or the quality of it. And I think that would be, if you put it in your paper, then it explodes the 8 pages format. But I think it would be great to be able in the Digital Futures in the future to include this data sets also as in for instance computer science, so where it's quite normal that you have data sets also part of your uploads there. It would be really nice for when reading it. And so we have, for instance, some PhDs and researchers which are super deep in machine learning and like that to read this and then to understand like also the technique and like to understand like what are the problems maybe with the approach you have chosen on a technical level. So thank you very much, Wenjing.
Very good.
Thank you very much.
We come now to Andrea Macruz and like measuring human perception of biophilically-driven design with spatial microexpression analysis and EEG biosensors. Hello, Andrea, again.
Hi again, Martin. We are doing this research with Jaime, Ernesto, Ricardo, so they are all here. So I think we can start. Okay, so Nimen Hao, our paper is called Measuring Human Perception of Biophilically-Driven Design with Facial Microinspections, Analysis, and EEG Biosensor. In this slide, you can see the workflow diagram. Our research is in between nature, neuroscience, design, and new technologies. So biophilic designs refer to humans' innate connection to nature to improve spaces, health, and well-being. Our work was based on papers related to the research, neuroscience research of Omid Kardan, Nikos Adingaros, and Jarty Jajji, and with the contemporaries advanced in neuroscience, digital technologies, and quantified selves practices, it's possible to extract information from ourselves interacting with the objects we are creating and analyze it to understand further how these interactions might be affected by the object's design. So we humans have evolved as a species in outside environments. However, currently we are spending 90% of our time in indoor environments. So there is a discrepancy between the type of spaces that made us and those that we are experiencing. What is the impact of that in our bodies and minds? So these are the parameters that we used in the research related to biophilic design and human survival strategies. Our departing point was that pattern recognition and inductive thinking are special abilities of the human brain. Finding patterns and figuring it out logically what those patterns suggest about what will happen next is very important. So therefore, shapes determine how fast an image is perceived, understood, and recorded. We have evolved to register, investigate, and prefer certain forms over others in fractures of a second. So this fact may help explain why patterns constantly appear in human design. 2 workshops were used as a vehicle with 47 participants composed of undergraduate and graduate students of architecture and design. The first workshop at Digital Futures 2020 tried to find clues to natural elements of human perception that could inform the design to meet goals for well-being. And by referencing biological forms found in nature, we utilized an algorithm process that explored how nature can influence architecture and design. So we introduced technologies and methods that allowed the use of neurodata and pattern recognition as feedback for the design process. Because of that, we are able to evaluate the drawings that achieved higher monitored meditation levels and also pointed towards a positive emotional balance. And the second workshop at SIGGRADI 2020, the same analysis was done, but without colors to reduce variables. It just focused on shapes and geometries.
All right. A little words about the methodology for modeling. Once the biophilic design concept had been introduced, we started the algorithmic modeling. We focused on the methods that had the most potential for applying these concepts and biophilic patterns. The tools were used was Rhinoceros, Grasshopper, and some plugins like Mesh Edit, Mesh Tools, Pufferfish, and Weaverbird. The time of the training was short, so and also the participants did not know how to program. So we decided not to work with code programming routines and recursive functions. The generative growth was presented with examples that exhibit recursive logic without the need for loops or recursive functions. For this, the golden ratio was used for incremental scale and rotation, and the Fibonacci sequence was used as a variable for the translation. This was possible due to the recursive nature of these mathematical constants, which have been found in patterns in nature. Participants were instructed to recreate shapes of the geometric basics of the biological system chosen by them. We consider similarities and differences of organic forms with North surfaces and discuss the attributes to define strategies for meshing, subdividing, and populating surfaces. We demonstrated adaptations of one algorithmic definition to different base geometries to promote design alternatives. Next, definitions were shared with the participants to build upon these or to use as reference for developing their own design ideas. Later, participants were directed and advised in the development of their proposals.
One of the methodological strategies that we adopted was analyze participants' microexpressions using artificial intelligence algorithms, such as artificial neural network and supervector machine. First, we selected 5 of projects most aligned with the biophilic design created in the classes before. Making with these projects a 7-minute presentation, we used as a stimuli to elicit reactions on the participants, asking to them to watch these videos, these presentations while recording the video self. After, we used this video self to capture the facial expressions using an open software named FaceOSC that sent this data to an interface. Based on the previous version that classifies state of poetic presence in performing arts, this interface was trained using an actor facial expressions in reaction to the Geneva Affective Picture and Database, GAPT. This database was designed to trigger the viewer's emotional response according to 3 emotional valences: neutral, negative, and positive. Designed on MSP, this interface analyzed and ranked the participants' facial expressions using the machine learning library for gesture recognition. Therefore, it can correlate participant expressions according to each emotional valence category caused by each project using their video selves. It delivers graphics that allows us to infer subjective relations, correlating that 7-minute presentation to the intensity of the valences to time.
So under this described scope about our EEG biosensor experience, we have been using since the beginning of our research the mind wave sensor from NeuroSky. It's a cheap and flexible device to measure brainwaves. This device provides several algorithms embedded in this circuit, which allow us to get not only raw data, but also some filtered results, our meditation and attention levels, and some additional data as well. During our research process, we developed an application based on the open source IDE called Processing. This application allows us to get brainwaves data in a determined time range, while static renderings of architecture projects are exhibited on a large LED screen during 7 minutes. After this analysis, with all the data processed, we can determine how the design, shapes, and colors can affect our brain perception, getting values of relaxation and anxiety by each 3D render. In our last workshops, we have been testing these neural impulses during 2 different stages. The first one in the middle of the creative process, and the second one at the final presentation. These results can help architects and designers to change their approach, developing different possibilities with the aid of parametric design tools like Grasshopper and Rhino.
Thank you.
Jaime?
Yeah, Jaime, are you there?
I lost the microphone. Oh, okay, again.
Just a conclusion.
Just a conclusion. The results point us to a deeper level of understanding about geometric shapes and design. In the first workshop in the projects that indicates positive emotions and a higher level of monitored meditation levels present symmetric shapes, fractal geometries, and softer colors blue or green. In the second one, were the ones that had circular forms, growing sequence, or harmonic continued curves. In general, fewer or discontinued curves elicit significant lower meditation levels. The combination of a biosensor and a customized interfaces for facial microexpression analysis allowed us to understand biological feedback and to synthesize geometries that trigger an automatic response. This work demonstrates how designers in the age of artificial intelligence may use science to design spaces developing humanistic traits and abilities to enhance the built environment. The methodology allows us to begin forecasting how design could respond to human interactions. Continued research will grow our analysis. For a stronger conclusion, methodology produces considering individual difference. Allows step might include augmented reality and interactive holographic experience in the expanded immersive spaces to test the morphology of the project.
Yeah. That's it. Yeah. Thank you very much.
Thank you.
Thank you very much.
Thank you very much.
Thank you. Thank you very much.
Thank you for your presentation. Please hold on for some questions here. And again, like congrats. Like it seems that like the Digital Futures workshops are a really good driver for kind of like overarching design teams to come together, and like you're able here to combine quite an immense set of questions. So from biophilic design, how you abstract like design into geometric bodies, and then to evaluate it, etc. So I think it's a very large, and I think like when I read your paper, I stumbled upon one question sentence where you said there the methodology allowed us to begin to predict and forecast how our design could respond to human interaction. And I find like that, maybe you can delve on it, because I haven't found this really in your presentation or in your paper. How do you predict it? So like, because it would be like a feedback loop. At the moment, what you're doing is you analyze like the kind of design outcomes, say like algorithmic design, and then you use like facial like expressions to kind of then give a feedback, right? So like this, but like how do you feed, like how do you close the loop? So like to say like the idea of self-improving design, or like something where a designer could present something. And so please elaborate here.
Ernesto, do you want to answer, or I can? I will start,
Yeah,
and then you.
I could. Okay, let's go.
Okay. No, you can go, and I will go after.
Well, yeah. Our idea initially it's to relate what the outcomes of these data is telling us about how people perceive those designs. So the idea is to create a large database of this information, so that we can specify the pattern that is behind some shapes and some forms. So we can use that as instrument for design, for future designs. So it's more or less like saying, yes, we are trying to demonstrate why curves are so interesting for human perception. But what kind of curves and why are this way? So this is pretty much the idea, like making tools for future designs, some kind of.
Yeah, okay.
Yes.
So there's a bit like work pending to get this into a, say, machine learned algorithm which could feed back. I think maybe commenting a bit more than questioning, also as a like the panel design here was very optimistic in terms of timing, but I think it's very interesting work that you have done. And like I mean, for sure there's like, I think like it's similar to other presentations today, there's kind of a underlying, there's a level of technology, which is like and then there's the underlying architectural method or belief system. Now in this case, biophilia, right? And so you need to actually evaluate your work. You would need to like, or say like, I think generally, like you can say like getting data on how people perceive that they like spaces or architectural design is really valuable, because we have too little of that, obviously. But the other question is then whether this is really linked and how can you do it. And so that comes to questions of bias and methods. So where like saying like biophilic design is really interesting and has a lot of layers, right? And you reduce biophilic design to a two-dimensional, maybe animated pattern. And so I think that's already pretty much constraining it. And also then you call it architectural design, but it's actually pattern design that you're doing, right? So maybe that would be interesting to discuss, like how can this method that you have on a technological level actually expand to really perception of architectural space, or also feelings which are different than looking at like a flicking of 7-minute presentation of different designs, because that's for sure very limiting. And then it's also like the person who designed it, her or himself, then looking at her own design, which is, you would probably be already very biased. And so maybe there's some kind of interesting move forward where, Andrea, yeah.
I think it's important to clarify just one thing. The person that did the project didn't analyze it. We selected the ones that they didn't do. And the second thing, I think that you're right about biophilic design, but that's why we joined with neuroscience, because for instance, the work in neurostatics, you have a lot of data parameters from biophilic design analyzed already and measured already about rooms, and they reduce this data for now, at least, to pictures as well. So the medical doctors are doing fMRIs and doing these scanning images of the brain. with 2D images for now. So all the scientific papers, we follow the same protocol. And there is one participant here that helped us to do the protocol. That was Tan Wu. She is one of the authors. And she's a doctor from a really good hospital here that does the autonomic research in that hospital. So she just deals with that. And she helped us to do how much time we look to each image, how this image could be, how do you say that? How this image could be randomly put, so you eliminate bias. So we are following the same direction. I do agree that in the future, doing that to VR, if we look to ANFA's conference nowadays, they are applying VR at some parameters, really little the research that you have, but it could be very interesting. But for that, I think the technology has to evolve a little bit so we can go into that direction. We hope we can do that in the future. Yeah.
Thank you very much. And I think we need to cut off. I think it's a great collaboration you have, and like the questions will probably evolve into more complex and other designs. And I think, yeah, please continue, Andrea. I'm very excited. I think we need to go on, and like we have now like Cheng Yushun and Xiong Li and Brian Hu from visual behavior to signature design. And I think they're, like as Andrea mentioned, VR, then we now we'll see like a really nice application of VR in a real live setting. Thank you, Andrea.
Okay,
thank you
very much. Bye-bye.
Thank you.
Thank you. Bye-bye.
Very good research.
So what? Cool. Now we are missing Sheng Yu or Xiong Linjiang Berlin. Somebody from the team here to present? No. If not, then I would propose that we move over to Rizu Na and Haosheng Dai, like from the last paper, A Framework for Cyber-Physical Human-Robot Collaborative Immersive VR Interaction, the Buzar Ball 4.0. No. Hello, Rizu.
How are you? Yeah.
Nice. Thank you very much. Rizu, are you sitting in America or where are you located?
It's just a background.
I just wonder like about the times you have here together, because your paper is like also in Los Angeles, right?
Yeah, I'm located in Los Angeles. Yeah, so I'm gonna share my screen. Can you let me know if you can see my screen?
Yes, thank you very much. Works very well.
Yeah, then I'm gonna start. I'm Rizu Na, an architect and researcher based in Los Angeles, California, and this is a research we accomplished with my teammate Haosheng Dai, and I'm gonna present it today. And yeah, in this project we presented a human-robot collaborative mixed reality application. The name is Box 4.0, in which a real-time interactive hybrid and physical architectural environment were designed and experienced like through the tools and methods of mixed reality, cyber-physical, and teleoperation, telepresence, and automation, etc. The application engaged the user and the observer in a continuous loop of architectural transformation. And during this experience, where every type of sensor is blurred between the digital and the virtual world. And from the concept point of view, in reference to the new virtual environment of Industry 4.0, and we propose a contemporary version of Box Ball, which is a historic social environment where participant is not only the human, but also the like iconic buildings in the forms of costumes and the other kind of stage design elements. And this is a picture from a Box Ball taking place in France in 1931. And you can see in the picture the there are people in costumes, and there are also some cross-designing acts. And I think it is questioning the presence of a human in a social space and requiring the participation of some kind of design elements in the social space. So this kind of spirit of sprawl and some other kinds of historic costumes have been a precedent to many social virtual reality platforms today. So in our cases, Biosensor 4.0 is an interactive mixed reality environment in the tradition of architectural league of New York sprawl and with the context of fourth industrial revolution. And in our project, we explored how to bridge between the physical and digital world with a system of like sensors in a spatial context and expanding upon the current version of the mixed reality. In this process, both the users and both users and robots are represented as an avatar in the scene, and they're going to interact together to build the aggregated environment. And the digital avatar and augmented Coco robots are actors in the scene, and they're going to interact based on the user's inputs, like headset and hand controllers input, and some behavioral patterns based on machine learning. And from a setup point of view, like each participant is going to wear a HTC Vive headset. It's a consumer-grade virtual reality headset, and that's going to determine the position and location of the like users in the virtual scene. And you can see in the picture there is a portal. There is this projection screen. It's like a portal from the physical world to see into the scene, and there will be an observer, like kind of a third-person view to see the interaction. And in the scene, robots are represented as avatar too. And they're gonna interact together to build this aggregated environment. In the nature, the large masses of like substances like sands, stones, gravels, like they're gonna form the landscape, like many kinds of landscape and objects through the process of flow and erosion. And we're gonna want to like imitate this kind of behavior or process in architecture and create its own configuration. So in our project, we explored this kind of interaction or a construction process of an aggregated spatial enclosure through some granular materials. So these particles were not bonded together in this process. It's just interacting through the forces between. So we would like users to like experience this kind of unique property of the solid material is very stable, and it's also like a reconfigurable as a fluid, like something like that. And the construction event was executed with the participation of both avatars and robots in the virtual reality scene. And users can both control the avatars and the robots to construct. And we selected some structures like walls and some triangular ceiling structures or some columns to visualize or much more efficiently communicate this interaction process. In this configuration, the avatar is kind of a spatial and abstract representation of the users in this event, and the avatars is also designed as like related to aggregated environments, aggregated elements, and during the construction scene, users can like shoot the particles, like controlling the hand controllers to shoot the particles into the scene and have the construction process, or you can just even like use the physical gestures like shaking or hitting the particles to like it's kind of an interaction. And in this process, we use a 3-point tracking system, like one like including the headset and 2 hand controllers, because in our cases, we are much more like focused on the upper limb interaction, and the user is gonna pay more attention on that and not gonna like pay more attention on the upper limb interaction and communication latency, but not the like accuracy of the full body motion tracking. So we're gonna more focus on it's more fluent and much more efficient interaction rather than just the accuracy of the motion tracking. And so as part of an experiment, we performed a random dancing experiment to verify the validity and effectiveness of our method. As shown in images, some random poses in a free dancing process were shown to prove that our method could estimate feasible and very stable motions. And as other parts, 2 augmented robots were the remote representation of the KUKA robots we use in this scene. They were set as an assistant of the avatars. So on the one hand, users can also shoot the particles in the scene. On the other hand, they're gonna sweep the particles out of the scene like not used particles. So it's one kind of like data cleaning process. It's gonna make the scene much more fluent. It's kind of from the, it's gonna save the memory because it's in the Unity's engine. It's gonna like have, it's much more efficient if you clean the data like at the time if you don't use it. So from the setup point of view for the robots, we set up like this scene in the Unity engine. There were 2 game objects for each robot. One game object is robot group, and another one is a robot ghost. Like the robot group is the robot you're actually seeing in the scene, and they're gonna match the physical robot in real time, synchronized motion. And the robot ghost is like a data structure, like because when we tracking the data for tracking the motion data from the hand controller, it's gonna like because hand controller is not very stable and there's a lot of like unnecessary behaviors of the users. So we're gonna have a data filtering process. It's gonna like filter out some outliners and some not good behaviors. It's gonna like put that data into the robot ghost, and the robot ghost is gonna send that data to the robot group. And the robot group is gonna calculate the joint rotation data from the A1 joint to A6 joint, because this one is 6-axis robot. It's gonna send the data to the by UDP connection to the robots. So as a result, it's gonna like we can see from this projection screen the robot and the actual virtual robot in the scene is gonna match perfectly. It's not gonna like moving around and have a latency problem. So as a conclusion, in this project, we propose an immersive mixed reality human-robot collaboration experience by imitating the construction process of large-scale aggregated spatial enclosure. And this application opened up, I think this application opened up a new possibility for architectural immersive experience, and where the sensories of like colors and materials and spaces, objects blurred between the physical and digital world. And on the other hand, it also opens up the new possibility for the social environments. Like it's not gonna just include the people in the like different spaces. it's gonna also include like artificial intelligent objects, robots, and some AI environments that are responsible and actively engaged with the social life of this context. So,
thank you, Ritu, for your presentation. Thank you very much. I think Philip said beforehand that like there might be into another paper that there are very many questions in a room, or it's a very complex project that's similar to you. I think like it's a very beautiful design that you have done, but there are so many aspects to it. So I think for a paper, it would have been beneficial to cut it down a bit, like the questions, because you're like it's very broad. I mean, I want to congratulate you on the digital workflow that you have established. I think like similar also to others in the session here, it's really amazing like how you fluidly link like robotic control data with VR and like a real-time representation. It's quite beautiful. I think so like my maybe like, and so that's like the benefit of it. And I would be interested in like how the experience was when you were standing there, because it's for sure not so much what you have like written about, and then I can criticize it a little bit more. But how was it what did you feel when you were in it? Did you feel it was immersive, or did you feel the presence of the robots? I mean, you hear the sound of the kukas moving, or what was it like?
Yeah, it's like in this scene, you can see there's on the right-hand side, that guy's, there is a HTC Vive headset. It's like emerging in the virtual reality environment, and it's controlling the avatars and the robots. And the left-hand side, that guy is like seeing from, it's like a theater. It's like you're gonna see from a window or see on the stage what's going on the stage, right? It's like there is a actor showing off on the stage, and you're gonna see it.
But I mean, like that's really okay. So really nice. I mean, like from a like asking a bit more, like then you're kind of set out like that, like about collaborative human machine interaction. And like you reference it as the Beaux-Arts ball, like, and the ball is about dancing. So you're one-on-one with somebody. And so I wonder, wouldn't it be better to use actually robots who are able to collaborate? Because here you have like the security fence, and you're obviously very remote to the machine that you're controlling. And so do you think like for a future perspective, would it be more or better to actually really engage, that you can walk around the robot while like now you force the person to be very far away?
Yes,
so if you could imagine your dream scenario, would this change than what you have?
Yes, I think that is a really great question for the human-robot collaboration, because in one aspect, human-robot collaboration is like where we are standing together and doing one thing, and another thing is like we are standing in a different position, and in the virtual scene, I can see robot is going what he's doing, because like this large scale robots is gonna really like there is like operation problem and security problem if you move really close to that. And it's kind of like, even if you're like, even this robot is in, like for example, the robot is in China and the user is in America, you can just put in the virtual scene and you can see robots moving, and you can actually like build something if the accuracy is not a problem. But in our case, we just want to like pull out this question, like it's not that kind of collaboration, like you can see me and I can see you, we can do something. It's like a more digital, and we're collaborating in the virtual space, but it's actually happening in the physical space.
And could you, so like then if you say you are in VR space at all, would you also think that you could do this completely virtual, or like it was similar in the setting that you described now? I'm in America, the robots are in China, so could you do this whole thing in a simulation? So without the robot? Maybe too complex. Because I mean,
yeah, Martin, I want to add something because it's a very interesting paper. Actually, where my team is also doing the similar research. This year, because of the COVID, we have some students abroad, not in China, but in South Asia, in Australia, in Africa. So we try to teach them how to implement robotics. So we develop a special platform and to try to introduce the robotics, and they can actually control onlinely, and it's thousands of kilometers away, but they can fabricate something. It's in a quite distance, another space. So it's a kind of new collaboration between machine and human. Which in different space. And I think that's already done. Very popular research right now in robotic human collaboration. So I quite appreciate your achievements. Actually, I think the best, the most interesting of your paper is kind of artistic reorganization by the linguistic ways to recognize a certain kind of new beauty of immersive for people for their behavior experience in a hybrid, both physical and online space could be integrated together. A lot of potential possibilities on this platform. So where are you from? From UCLA or from Super Studio?
Yeah, I'm from UCLA.
Okay, I can see the, it's really good. Greg Lin's team is, I think you are really make some advanced research. It looks easy, but actually how to capture the precision of the human behavior and robotics should simultaneously feedback from your behavior is very difficult, But you can hybrid these two kinds of environment very well. That's you make very good achievements. I'm looking forward. I think the paper may be not long enough for you to present all your research. So we are looking forward to invite you to extend your paper in another book we want to publish, Material Intelligence, to extending your paper in that longer, that's 10 pages or 12 pages paper to present your project. So hopefully you should introduce more detailed technology details in your research to the readers. So thanks a lot. I think it's a really good, really interesting research project. Thank you. Thanks.
I appreciate that. Thank you. Thank you very much.
Thank you, Rizzo. Congrats. Cool. So now we move on to Yang and the last presentation of this session. And like announced it already before, it's a really large VR project you've undertaken with an amazing large data set. So welcome here from visual behavior to signature design, a wayfinding experiment with eye tracking and satellite terminal of PVG Airport, conducted at Tongji University Research. And Yang, welcome here.
I'm sorry, I'm back now, and today I will give a presentation about our research about wayfinding, sorry.
Julia, we can okay. Oh, yeah. Something is coming here now. Good. Whoops.
It seems.
Julian, it's okay. Like just like start here, and the view. We can see the PowerPoint slide now. It's very nice. So you can just
okay. Okay, let me go on. As we all know, transportation building is an important type of architecture in wayfinding research. Passengers usually have clear wayfinding purpose in transportation buildings. So it is necessary to design a perfect design perfect signature system to improve the wayfinding efficiency. And wayfinding behavior is related to human cognition. Actually, according to wayfinding research, space and the signature system interactive with each other and affect the visual behavior of passengers. Well, designers tend to ignore the passengers' wayfinding behavior when they design the signature system and wrongly assume that wayfinding is synonymous with signature. As a result, the signature system could not satisfy the passengers. Take PVG Airport as an example. The satellite terminal of PVG Airport is a typical mega-scale transportation building with 134 boarding gates and approximately 3,600 signboards. Inside the building, the interior space along the working path is extremely similar. Besides, there are intricate passenger paths in the satellite terminal, with paths from entries to gates always take half an hour on average for passengers. These pictures on the right was taken in the international departure, and the domestic departure is right below this floor with a similar layout. And the high-resolution panorama was taken at each wayfinding decision point. The decision point means that passengers need to make a decision to like turn left or turn right or go forward. And we rebuild a low-detailed 3D models of interior space of the satellite terminal according to the beam model. And the panorama is projected on the 3D interior model, which have a better stereo visual experience. And then the interior space of the satellite terminal of PVG Airport is reproduced as a virtual reality scene. And we named it digital twins of PVG Airport, just like this picture. And here is the video about a person experienced the sorry, it cannot play.
Zhang, I think it's okay. Like it's a person in a VR setting.
Yes, it's a person experienced the virtual wayfinding platform with a helmet, and the next page. Sorry. The pictures on the left shows that the trajectories of all participants when they wayfinding in domestic departure. The trajectories of the participant is the connection of the wayfinding decision points by the time sequence. Of course, we can analyze a specific wayfinding task just like the right pictures that shows the trajectories of passengers search for the H138 gates in this floor. And in fact, we think wayfinding is a dynamic decision-making process. So the trajectories can only reflect the correct or wrong decision, which made by the participant, but it cannot be used to explore how the participant make the wayfinding decision. compared with the trajectories, we pay more attention to which factors like space form or signature system or electronic scripts and others. How these elements affect the participants to make the wrong wayfinding decision. I think which is very important to for the future design optimization. Eye tracking technologies can provide a great help for this research. We select 8 wayfinding decision points where participants make a wrong decision frequently in virtual wayfinding experiment as a trio group. And another 2 wayfinding decision points with no record of decision wrong. Decision error was added as a control group. The random shift error represent the initial view angle of the participants before the experiment starts. And there's another video. Sorry. You cannot show. So let me go on. This is eye tracking data of the participant when he search for the information of this gate in international departure. We divided different observation area and displayed the eye tracking data on each observation area respectively. Because the fixation area and the gaze path will change when the people turning hand. So different observation areas should be differential from more accurate analysis. The observation areas are also sorted by the time sequence, and the order is represented by the red number, just like this 1 or 2. And through the analysis, the eye tracking data of one participant, we can explore the visual behavior of this person when he search for the gate. Just like he will pay more attention to the escalator and the luminous fingerboards. However, we want to explore the universal visual behavior of multiple participants at the same wayfinding decision points, because we think this universal visual behavior is related to interior space form. So we project the gaze path of multiple participation on the panorama of this decision points, but it seems not easy to find out the common visual behavior as this diagram. So we change our mind and we use the color code to label the interest area for participant, and we define that the horizontal coordinate as the hue value and the vertical coordinate as the brightness value. Considering that the fixed duration of each participant is different, because it's at least 4 seconds, and the maximum is 13 seconds. So we pay more attention on how participants allocate the observation time. So the proportion of fixed duration is better more informing than absolutely value. By analysis, this bar graph in the right, we can easily find out that the people tend to observe along clockwise direction. That means always they always observe from left to right. Meanwhile, fixation duration presented on the building layout, the radius of the sector represented that cumulative value of the 8 participants of this 8 participants observed time, and then we know that people pay more attention to the right hand rather than the left hand, and just only a few people noticed that there is passages on the front left. Combined with the above data analysis, we summarized the 3 kinds of visual behavior of passages in wayfinding. It likes the reconfirmation behavior, the priority of attention, and the clockwise observation. After sorting out the result of the wayfinding experiment, we proposed a guideline for optimizing the signature system design. The guidelines will be used to guide the signature system design in the future. Okay, let me give some examples. This panorama was taken on this wayfinding decision points before the optimization. We can see there are a little available wayfinding information in our vision. Since at this decision points, so we two redundant thinkboards are removed, and another 2 thinkboards was added to ensure the continuous of observation. And this panorama was taken at another wayfinding decision points of domestic departure. The wayfinding information on the thinkboards should be coherent to ensure the information can equal with each other. As shown in this picture, the 4 redundant thinkboards was removed, and a crossroad thinkboard is added. All the wayfinding information appeared twice on the thinkboard, so the passengers can easily conform. And we redesigned the layout of the thinkboards, such as the pictures. We think the process wayfinding information, just like departure, arrival, and boarding gate, is the most important, and followed by the information of the function facility, like restaurant and shop, shop, and restroom. We can differentiate wayfinding information by design it as luminous or not, in different colors and different sizes. The approach for data visualization based on the color code proposed in this paper provide a new perspective to analysis eye tracking data. And it is helpful for us to directly analyze the relationship between the visual behavior, the signature, and the interior space. Up to now, in some wayfinding decision points, which optimize the signature has been constructed. The signature effectively guides and divergent passengers, and it is welcomed by the passengers according to the feedback. And the construction of this optimized signature system has not been completed now. So we plan to evaluate this new signature system after its completion and compare it with that signature system before optimization. And in our research, we also have some interesting. We also find some interesting things, just like the visual, the passengers' visual behavior. The passengers' visual behavior will be affected by the surrounding people. And another thing is. And another thing is we found that it is similar between the heat map of the object recognition in computer vision and the heat map of the eye tracking data, so which can be used to explore the relationship between the spatial form and the visual behavior. And that concludes to my presentation. Thanks for listening. Thank you.
Thank you, Shu-Yang. We're probably late on the session, so like maybe it's just some quick questions. First, congrats, it's a really amazing study. I guess you have it's a direct commission by the airport that you have done, or how did this project come together? Yeah. Okay. Have you done similar projects before, or what is this based on? I mean, and you reference some other papers and eye tracking work from other authors beforehand, but is your institute focused on this type of research? Maybe one other question, just to round up here. So this is now say post optimization of a very famous airport, and do you think that the same technology could be used to say figure out what the right signature system would be before you build it? I mean, looking at the amount of money.
Yes, we think that the heat map is an approach for our to explore the interior space design, and from this heat map we can know the visual behavior or the human's perception of something and I think it is helpful for us to evaluate our design or nothing.
Yeah, I think that, or even maybe just putting, you had 175 people in your study, I read. So I mean, maybe that's not so much money, and if you compare what it if you would use those 175 people before actually putting up all those signs, before in the design process of signs for an airport, right? So I think now you probably have the cost of commissioning of people in the study, but then also changing all those signs as you now concluded, which is necessary, is quite a heavy cost in a running airport. So maybe this tool that you've developed or approach would be really nice to use in the future before you even, or while you plan and build a airport, which is still several years long. So you have ample time to take Zahad's design and then check it. Right? So, Cool. But I think.
Okay. Thank
I
you.
think that we should conclude now that like Philip, you can start with the next session as well. Yeah.
Great. I think it's quite fantastic for all the speakers today in this session, since we have very high quality and showing different kind of new technologies. So that's great to give a special opportunity to all the PhD researchers all over the world. And DigitalFuture actually produced a special platform in the past few years. So among them, they collaborate across different countries, and some of them become couples on the platform of DigitalFutures. So I can see that it's really an inclusive platform to have different potential possibility to see what's happening all over the world. And thanks a lot for Martin chairing this session, and he is actually from CETA, Denmark. That is an extremely interesting lab. There I visit once. I think it's in a very beautiful island and produce a very primary research, play the leading roles across the world. So thanks a lot for your sharing. So we need to move into another Zoom. Another space, because we have one more session waiting for us. So thanks a lot.
Thank you.
And all the presenters, thanks for your papers. Thank you.
Thank you very much for this hours here, and see you in
bye-bye.
Copenhagen or the next session where we present as well. So congrats everybody. And, yeah, very excited to see the rest of the conference here. And yeah, okay. So let's move over.
Yeah.
Bye-bye. Bye-bye. Bye, Philip.